unfortunately perished in a garage fire.
Oh,
A barn fire would be more. Are we live?
we are live.
I'm gonna mute
We are
myself.
live. We got a little bit longer, um, intro. It makes it so I don't have to really rush sharing the show.
I'm gonna take my dog outside real quick here.
We have a small group so far. Maybe some people are still wolfing down dinner.
Wolfing. Yes, they're wolfing. Like me. Uh-huh. That's an old saying, wolfing down dinner or wolfing down anything, right?
I like wolves. They're cool.
Smart.
They are.
They are. Yeah.
David, have you ever read the book Never Cry Wolf by Farley Mowat?
I've heard of the book. I've never read it though.
Oh, it's wonderful. It's a Canadian story, not very long. And at the end of it, there's a scene where he happens to get into a cave and he's looking in the back of the cave and all he's seeing are these multiple pairs of eyes looking back at him. And they're all wolves.
Ooh.
And he thought, okay, I had a nice life, but all they did was look at him. They didn't do anything. They didn't hurt him.
Huh.
And he stayed there with them for a little while and then backed away. And it was fun.
Oh, that's cool.
Wonderful book.
I'll have to look that up, David. Thank you.
Yeah.
I always like the stories of kids being raised by wolves,
Mm.
I try to, that was always something that, somehow always caught my attention. Anytime that somebody is raised by wolves, I thought, wow, that would be kind of cool,
They can turn out well-mannered, but sometimes a little bit hairy, though, is the only downside. But it usually works out pretty well. Yeah.
That's right. Their life doesn't go to the dogs, I guess. Huh?
Ooh. Now we're treading upon Clyde's territory here.
Oh, very dangerously, too.
That's right. Uh-huh. Yeah, you were barking up the wrong tree with that one, so.
They say that
Okay, it's
Romulus
starting
and
to get really
Remus
bad.
were raised by wolves. And then they grew up to found Rome.
Yes, that's right. Yeah, the founders. David, I liked in your book, in your Clyde book, you mentioned at one point a young co-equal at the observatory was rebuilding a house and had a lot of brickwork done, if I remember correctly. And Clyde said, well, I'm glad it came out okay, but for a moment I was mortified.
Yes.
Oh, that's priceless, David. That is priceless.
Mortified.
Only Clyde.
Mhm. He doesn't, you see pictures of him and stuff, and you don't think that, he's kind of this kind of guy.
Yeah. He was something else.
He never developed a sense of humor until after he got to New Mexico, I think.
Mm.
And he really picked it up fast when he was at White Sands.
Mm. Hey, Cesar, how's it going?
How are you?
Good. Good to see you.
It's a honor share with you and David Levy the first time. I returned later, but
Yes.
hi.
Good to see you. Should be a good night.
Yes.
Really. I loved your Instagram post, Cesar.
Hi, how are you?
Doing great, man. I loved your angry clouds over the city. It was awesome.
Absolutely. Yeah. Yes, a quote of imagination and right over the clouds and, a little of humor. Yes, I returned to the global safari after my wife take COVID and she's fine, but we had 3 weeks a little complicated, but all is okay again.
Good to hear.
David, what is in the magazine? What kind of articles are devoted to Mars this time?
Well, there's a big Perseverance preview, of course, story that Jake Parks did. That's about a 10-pager. You know, it's hard for me to remember what's out right now because I'm planning the September and October issues now. So I'm thinking in a different chronology than what's going on right now for the most part with the magazine. But that's the big one. There's a big scientific Perseverance preview story.
Oh, that's great. That's great.
God, are you going to live stream for the landing?
I don't, you know, I don't know how to hook into those things, you know, and share those. I think what I'm going to do is I'm just going to recommend that they, you know, before they go live, because they're going to go live about, I think, 2:00 Eastern, something like that. And I'll just put up a bunch of links and stuff like that people can make sure that they get to see that information, you know. I certainly want them watching it. You know, it's okay to take a back seat to something like that. That's for sure, you know, so.
I'm sure the presentation will be awesome. I can't wait to see it. Probably be watching it on a few different screens.
Oh yeah. Yeah, my office will look like Mission Control. I'll have it on every screen.
I like when you watch you know, like the main feed of something, and then you might have somebody else who's covering the main feed, but they're coming to you in a delay. So when you think you saw something happen, you can like quickly look over at the other screen. It's been great for Starship Test recently because, you know.
Oh, sure.
It's like, okay, that just happened. Look over there.
Right. There's a new TV series. It's kind of like an alternate reality series about Apollo. And I think it's on Amazon Prime, maybe. Could be on Netflix. I can't remember. Acting in it's pretty good, but in this alternate reality, Russia lands on the moon first. You know, and you know, Neil and Buzz and Michael Collins are kind of waiting, you know, for the kind of how the Apollo 10 crew was so close that they could have landed, but they didn't land. And it's interesting.
That's certainly what the Soviet Union planned and hoped for before some key people, including their chief engineer, died and various things exploded on the launch pad and so on.
Oh yeah.
But they certainly
exactly
planned and hoped to beat us to the moon. And it would have been Gagarin and you know, after he died, then that also put the cosmonaut office into some chaos.
Yeah.
It would have been Alexei Leonov, our Starmus pal, who died a couple years ago, you know, would have been the first Soviet moonwalker had the program continued.
Hello, Libby.
How are you?
Oh, we're doing okay. Welcome back. We're doing okay here.
Hi, Libby.
Hello.
Libby, you're going to have to come to the office and pick up your book. I've got your David Eicher, Brian May book on the 3D book.
Yeah,
Cosmic
we're right
Cosmic
now.
3D Clouds.
Right now we're in like 1 feet of snow, and there's more coming down tonight.
Ooh.
So we're
You could
snowed.
ski down. You could ski over, like, you know.
My dad has a truck, so I'm sure we'll make it through the snow.
I'll keep it safe for you. Don't worry. But I've read every page already, and the edges are a little dog-eared and stuff, but.
Uh-oh. I hope that you'll be kind with your review, Scott.
Yeah. It's a great book.
Well, thank you.
It's a great book.
They've even been canceling virtual school with the snow some days this week. They've been canceling it, so I have all the time in the world to read books and do what I want.
Yeah. Well, you already have a bunch of people logged in. Book Davies is watching. Cameron Gillis, Chris Larson. Cameron's recommending that I restream the live broadcast from NASA. I don't think I can do that. Yeah. Chris, I gave a presentation to an astronomy club in Chile yesterday, and it was titled "The Power of Stargazing," and it's the topic is why stargazing is good for you. You know, so I'll have to share that presentation sometime. But this one was translated into Spanish.
I really enjoyed it, Scott. It was great.
Yeah, thank you.
Excellent.
Good.
Except I haven't had a clear night since January 12th.
Ooh, yeah, not here.
I figured out how to solve all the world's drought problems. What we do is we relocated an astronomer or astronomers to an area. We give them a budget. We put cash into their accounts, and we have them order new equipment. Okay. And as soon as it arrives, it'll of course start raining, you know. And then once the drought's over, then we move them off to another area. So these people get very little stargazing in because it's always cloudy and rainy.
Scott, my Zoom test was a little faint. Is my audio okay?
It's a little
Low?
little muffled, you know, but not terrible.
I don't know why.
Definitely readable.
How is it now?
Oh, really good.
Really good now?
Really good.
Better. Yep.
I think I had a loose connection. Thank you.
Yeah.
That Netherlands disaster was in 1960, wasn't it, David?
Mm-hmm. Yeah,
So they had 9 years to recoup from that, but I suppose they lost so many people.
Well, and especially Korolev, who was the chief engineer, and he was really irreplaceable. There was no one who had the expertise that he had, and so that really almost sort of deep sixed. Then they lost some other people too, you know, I mean, Gagarin, but some others in training flight crashes, as we did too, lost a few astronauts in fighter plane crashes when they were training, you know? Sadly enough,
It's dangerous.
Yeah.
Okay, we're going to get started now.
Nothing can be taken for granted when you get to Mars. There's a lot of things we just don't know.
Space always has a way of throwing us curveballs and surprising us.
I mean, until we get the data that says we're on the ground safely, I'm going to be worried that we're not going to make it.
Entry, descent, and landing is often referred to as the 7 minutes of terror, because it takes about 7 minutes to get from the top of the atmosphere of Mars to the ground safely.
The spacecraft has to do all of this by itself.
There are many things that have to go right to get Perseverance onto the ground safely.
There's a lot counting on this. This is the first leg of our sample return relay race. There's a lot of work on the line.
Starting about 10 minutes before atmosphere entry, we get rid of really the spacecraft part of the rover that's been supporting us.
We come screaming in to the Martian atmosphere at 12 to 13,000 miles per hour.
And the heat shield is what dissipates all that initial energy through friction.
The vehicle will continue actually flying itself through the atmosphere. It's sort of like a transforming vehicle that went from spacecraft and now it's kind of like an aircraft actively guiding itself.
When we're going slow enough, we deploy a parachute.
The biggest supersonic parachute we've ever sent to another planet. It's critical for slowing down the vehicle.
Perseverance's entry, descent, and landing borrows heavily from that of Curiosity.
But fundamentally, Perseverance is a different rover. She's bigger, she has different instruments.
We've added a lot of smarts on the inside to make it more capable so that it can deal with the land site that we've given it.
The science team identified Jezero Crater as basically an ancient lake bed and one of the most promising places to look for evidence of ancient microbial life and to collect samples for future return to Earth. The problem is it's a much more hazardous place to land.
You look at Jezero, all you see is danger. How do we go to a site that we never thought was safe enough to go to before? So the heat shield, which has protected us all the way through entry, is no longer necessary. We need to get that off so that we can actually see the ground. And we can see the ground in a couple different ways.
Perseverance will be the first mission to use terrain relative navigation. So while it's descending on the parachute, it will actually be taking images of the surface of Mars and determining where to go based on what it sees. This is finally like landing with your eyes open. Having this new technology really allows Perseverance to land in much more challenging terrain than Curiosity or any previous Mars mission could. Amongst the rocks and the craters and the cliffs, these things are hazardous to the rover, but these are the things that are interesting to the scientists.
Once Perseverance has figured out where she is, jettison the back shell and parachute, and light up our rockets. Those rockets help us steer to a safe landing spot that's nearby.
That descent stage takes us all the way down to about 20 meters off the ground.
That's when we start the skytrain maneuver. Once the rover has hit the ground, the descent stage will cut loose from the rover and fly away to a safe distance. Surviving that 7 minutes is really just the beginning for Perseverance. Its job, right, being the first leg of sample return, to go look for those signs of past life on Mars. All that can't start until we get Perseverance safely to the ground. And then that's when the real mission begins.
Pretty lonely there, doesn't it?
Yeah. Yeah. Well, hello, everybody. This is Scott Roberts. This is the Explorer Alliance's presentation of Global Star Party number 32. I was mentioning earlier that we've had other Global Star Party type events happen, and maybe technically this is more than 32, but as far as this format, this is the 32nd one we've done. We've accomplished that in, I guess, less than 12 months. So that's a lot of star parties in a year, right? But it's been really rewarding, I think, for me personally, hopefully for the audience and for the people who participate here. We really, I very much enjoy it. It's like every week I get to hang out with my friends, and I really treasure that. And so with us right now is David Levy, Richard Grace, David Eicher, Cesar Brolo is with us, Chuck Allen from the Astronomical League is here, Libby and the Stars, and Jerry Hubbell. We have more people coming on later in the show, and we have been given a little bit more active push towards people joining up to log in for the after party. So if you're interested, I will post the after party login link later. Rules are, as this is an astronomy show, so you have to stay on topic. It's a family show, so you have to keep it nice. And you know, you have to have Zoom, you have to have a good video and audio link. And so when you log in, you'll be checked out by Kent Martz, and then he'll give you the link to come on live onto the show. That will start around 9-ish, okay? But we, as we always do, we have David Levy, who is the author of A Night Watchman's Journey. This is a fabulous account of David's life, written by him, and just so many interesting aspects of David's life, from his challenges to his triumphs, and what it's like to discover a comet, and all of his friendships and I guess struggles sometimes with people that he's encountered in his life. But when I think of David Levy's contributions, all of his articles, all of his interviews with amazing astronomers, including Clyde Tombaugh, who we highlighted on the Astronomy Magazine's Global Star Party that ran just a little while ago. You know, it's Clyde's on the 18th. Not only will the Perseverance Mars lander be landing, but it's also the anniversary of Clyde's discovery of Pluto. So it's a double whammy on that particular day. And David, as we talked about on the Astronomy Magazine edition of Global Star Party, he knew Clyde quite well, and he's got a book about Clyde's discovery of Pluto that you should read if you have an interest in a really amazing individual, Clyde Tombaugh. David Levy is a great friend to all of us. It's wonderful to have him on. I like having David on when we do the countdown as well, because you know, he's able to talk with his other friends here on the Global Star Party, and you know, we all feel that he's very special. And so, David, I'm going to turn this over to you and give you the stage.
Well, thank you, Scotty, and it's welcome to everybody for the 32nd Global Star Party. These are an awful lot of fun. I really, really enjoy being here and being a part of the group, and helping all of you around the world to go out and enjoy the night sky. In the United States, you're probably having an awful, very cold weather right now, so you may not be staying out for too long. But even so, the cold nights are often the clearest nights to be out. February is really Clyde Tombaugh month. The last Global Star Party with Dave Eicher from Astronomy Magazine, we celebrated Clyde Tombaugh's birth on February the 4th, 1906. I like to say 1906. He was in the class, I say, of 1906. Fred Whipple was born that year. Bart Bach was born that year.
Wow.
I'd like to say that I was born that year, but that would make me 100 and some odd years old, and so I'm not going to say that. Anyway, excuse me. Anyway, the other thing was that on February the 18th, Clyde discovered Pluto. And I remember talking to him about it at almost every meeting where I interviewed him for the biography I was to write about him. And each time I was there, he always had some detail to add about the discovery of Pluto. And as Clyde grew older, he began to get really afraid and depressed about what would happen to the status of his planet after he passed on. And I know that he was really concerned, and he was very upset at the early International Astronomical Union efforts to deplanetize Pluto. And of course, that did happen in 2006. And there's still a debate going on to this day as to what the status of Pluto is. I am a part of the Retain Pluto as a Planet group, not for any scientific reason, but because I knew Clyde, we were friends, and I knew how deeply personal it was for him. Tonight's quotation is going to be from Clyde. in 1985, I was interviewing him for the chapter of the book was called Discovery's Wake. And we were just about to start, and Clyde just came out and he said these words, and they're so precious. I'm going to quote them right now. He said, "You have to have the imagination to recognize a discovery when you make one." When they examined Voyager images in 1979 and saw for the first time the volcanic eruptions on Io, that called for some intuitive imagination. I would suggest that above everything else in observing, you have to be very alert to everything. You have to be able to recognize a discovery as such. There are so many people who don't seem to have that talent. A research astronomer cannot afford to be in such a rut. And I would say that an amateur astronomer also should not be in such a rut. And Clyde goes on, I might say that different types of personalities in astronomy make certain types of discoveries that are in line with their personalities. And on that note, I give the floor back to Scotty. Thank you.
Well, thank you. That was great. It would have been amazing, I think, to have seen Clyde actually work, and his attention to detail. I just can't imagine it, because the giant glass plates that they had, and then the thousands and thousands of dots that would be on these plates. What is your point of reference? How do you notice that this one tiny dot has moved against the background of stars? I got a little taste of that when astronomer Jean Mueller, and she doesn't call herself an astronomer, but she's an astronomer. She worked at on the Palomar Sky Survey during the last run when they were actually using glass plates. And I had the honor of her showing me how she operated this telescope by herself. Okay, so this is the 48-inch Schmidt camera. The glass plate film holder weighed 27 pounds, I recall. And so I said, so how does it all work? And so she said, it's like this. And she opens up the door, the side door of the Schmidt camera. She releases the plate holder, 27 pounds. She takes it and she runs. Now we have the lights turned on, but she runs down the stairs. She goes into the dark room. She said, okay, now I release the plate holder and I develop the plate. In the meantime, she's getting the next plate ready. Okay. So they're using warmed hydrogen, okay, to hypersensitize these glass plates. She pulls out the glass plate. She puts it into the plate holder very carefully, because it's got to bend the glass to the curvature, radius of curvature of the Schmidt camera. Sometimes these things would explode, okay? And she would have to get another one ready very quickly and then lock it all down, get that plate developed. Often she would throw that plate up on the, on the light table so that she could just take a quick look at it. And she made many discoveries by doing this. Okay, she discovered many comets and asteroids by doing this. But these people, Clyde and Jean, knew the sky like the back of their hand. Okay, and so it was really amazing. I would imagine that after a while you develop a feel for it, but I looked at that plate from the Schmidt camera and was flabbergasted that she could tell anything was different, Anyway, she would then take that freshly loaded plate and run back up the stairs and load it back into the scope, close the door, start the exposure, and just keep this all night long. But she's doing this in total darkness. Okay. She doesn't have the lights on. So it was pretty amazing that someone could work like that.
You're talking about Jean, right?
Jean Mueller.
Jean Mueller. Yeah. I knew that she's also an opera singer. And,
I did not know that.
I remember one night we were talking about one of the very famous pieces of music written by a French composer it was an elegy that he had written, and she started to sing a few bars, and I asked her if she says she likes to sing it in the dome. And I asked her, I called her from where I was in our 18-inch telescope, and I called her and I said, I'm going to come by and I'm going to be walking by the dome in about 5 minutes, and I'd like you to sing it at the top of your lungs as well as you can when I'm going by for about 5 minutes. And I went by there, and the echo and the acoustics of her voice just resonated among the stars that night. That was absolutely wonderful. And thank you so much, Scotty, for sharing that story. One of the things that Wendy had urged me to talk about just now while you were telling that story was something that happened with Clyde and Wendy and me and Patsy in the last few months of Clyde's life. I wanted to go to take him to see Apollo 13. And I guess we didn't make it clear to him that that was the movie we were going to see. And Clyde was sitting there. He said, oh, no, I'm not going to go. And Patsy said, come on, we're going to go, just the four of us. We're going to see the movie. And Clyde said, oh, no, I don't want to go. And then Wendy said, Clyde, the movie we're going to see is Apollo 13. And Clyde just lit up like a candle. And he said, oh, yeah, I'm in. And we went there and we sat together. And every few minutes, Clyde would pick up some little detail in the movie. He said, I remember that. I was part of that. It was so exciting to see him come to life and revivify that day.
Yeah. Oh, that's great. That's great.
Yeah, to see him getting so excited, that was just a beautiful thing.
Yes. Thank you, David. That's great. Well, our next speaker is David Eicher. Now, David has contributed so much to these programs. I don't remember which segment this is, David, to be very honest with you. You said originally you do 17 of them. You did a bunch of them, and then you did a Global Star Party, and it seems like it's going on and on. And I love it. I really do.
This is only number 10, Scott.
Oh, it's only, oh, good.
7 more to go.
7 more to go. Maybe I'll think of some others that we can keep this rolling.
There are probably only about 1,000 things we could talk about.
Okay, that's good. Yeah. Limitless, yeah, a whole cosmos full. David Eicher is the author of Cosmic 3D Clouds, Where Stars Are Born. This is co-authored with Brian May, astrophysicist and lead guitarist of Queen, Brian May, and it's an amazing book. A lot of fun to read, just rich, of course, in all this imagery and the ability to see these objects in 3D. In the very back of the book is this special, what they're called light owl viewers, and this enhances the view, and so you'll pull these out and hold them just right, and you just get an amazing view through this book. So they are just giving you a really penetrating, involved, feeling when you look at cosmic 3D clouds. And, I think that, for people that are trying to learn how to find, get that feeling, how they connect with the universe, this is a great book to do that with. And so, Mr. Eicher, I am so happy to have you on the show again. And I'm sad now that we've already gone past the midpoint of your 17 segment series, but I think that it's going to be an amazing talk. So I'll give you the stage.
Thank you, Scott. And it's always a real pleasure to be here and to join such a great group of friends and distinguished colleagues here, all of whom are amazing. So it's great fun. I'm going to talk, that book is about nebulae, chiefly in our galaxy, but I'm going to go out even farther tonight and talk a little bit about galaxies out there in space as I continue on these crazy subjects. So something that we all know and love, standing out and observing the night sky, is our Milky Way galaxy, and seeing in various parts of almost any evening, if you're out all night, you can see part of the Milky Way, often in the summer evening sky or the winter evening sky. But of course, as Earth rotates, we can see the Milky Way on parts of any night, our own galaxy from within. It took a long time to sort of understand our galaxy, and it was only about a little more than a decade ago that we now know about the structure of our galaxy. It's a barred spiral galaxy rather than a simple spiral. It was thought to be for decades after our galaxy was understood, the nature of galaxies discovered by Edwin Hubble. We were thought to have a simple spiral galaxy like our big bright neighbor. Many of you know the Andromeda galaxy. That's a simple spiral galaxy without a central bar. Well, the story gets even more interesting, not only deriving the structure of our galaxy, but in 2008, about at that same time that the Spitzer Space Telescope was unraveling the structure of our galaxy's arms, a group of folks who were led by Avi Loeb, at Harvard University. He's the chair of the astronomy department at Harvard. And he's a very colorful character, great guy. He was written for the magazine. He's a world famous astrophysicist. He's involved now in the breakthrough Starshot idea to send micro robotic probes to the nearest star system, Proxima Centauri, all kinds of things. But one of his big breakthroughs, and he's also talked, by the way, recently about the interstellar Voyager, Oumuamua, possibly being a sign of an intelligent civilization. Don't pay any attention to that, okay? Because Avi likes to have fun, I think, with things and see how people will react. I'm sorry, Scott.
It's good.
It's, Stephen Hawking was very much like that too. He liked to claim various things once in a while to provoke a response and see how people would respond. And I think that's what Avi is doing with Oumuamua, is a sentinel from another intelligent civilization. Anyway, tonight we're going to talk about galaxies a little bit. You should pay attention to Avi and his study from 2008, in which he determined that the Milky Way and the Andromeda galaxies will become very good friends in the future. Because as we know from the 1920s onward, the universe is expanding. We know for some time now that expansion of the cosmos is accelerating, even since 1998, the discovery of this repulsive force that astronomers have called dark energy, for lack of any real concrete understanding of it yet. But we know that despite the fact that most galaxies are moving away and the universe is expanding over 13.8 billion years since the Big Bang, that local motions and gravity can bring galaxies together. And in fact, that's how galaxies evolve and grow. They come together and they merge and they grow from very small proto-galaxies into large normal galaxies like we see around us, nearby us in the universe. So that's what happens over galactic evolution. And we know that the group of galaxies that we're in, the local group, has at least 55 galaxies in it, maybe many more, because little dwarf galaxies, the ones that tend to get eaten up into larger ones, are hard to see. But this study in 2008 that Avi Loeb and his collaborators, chiefly T.J. Cox, took on, was the first one to look far into the future about the Milky Way and the Andromeda galaxy. And it's been known for some time that the so-called radial velocity of the Andromeda galaxy, M31, is 301 kilometers per second. That is to say that Andromeda at the moment here is moving toward us every second by about the distance between New York and Boston per second. So it's coming toward us with pretty good resolve, although of course the distances are incredibly large in the universe. The Andromeda galaxy is 2.5 million light years away. So it's a long hike. But they found, despite the fact that there's this dynamical dance going on of the orbits within the local group of these two big galaxies, the other one that's somewhat smaller than both of those, but is still a large galaxy, is M33 in our local group. But Loeb and his collaborators found that this dance will continue, and eventually the Milky Way and the Andromeda galaxies will merge and become one big chaotic super galaxy. And of course, Avi had to come up with a name for that future galaxy. And what do you call a merger of the Milky Way and the Andromeda galaxies? But Milkomeda.
Milkomeda.
So that is the name that astronomers have assigned the future super galaxy that we will be a part, our descendants will be a part of. Milkomeda.
Milkomeda.
That galaxy. That's what the chair, I'm not making this up, the chair of the astronomy department at Harvard, okay, created that name.
Nice.
Can't make that up, folks, okay? But so what Avi and his collaborators did was to produce a series of computer simulations. They used a total mass for the Milky Way of about 1 trillion solar masses and 1.6 trillion solar masses for Andromeda. It's a more massive galaxy than we are. Mm-hmm. And what they did was model the orbital dynamics of the systems from about 5 billion years ago. That's a short, relatively short time before our sun winked on as a nuclear fusion engine, to about 10 billion years from now, and modeled the orbits, the orbital dynamics of these two largest systems in our group of galaxies. So what they found was that the two galaxies will make a relatively close passage at first to about 2 billion years from now. Now, I don't want to disappoint you, if you were getting excited about this, because as Andromeda gets closer to us in the sky, for anyone who's around on planets orbiting stars at that point in time, it's going to be pretty cool. If you think the Andromeda galaxy looks good now, imagine it when it spans 90 degrees on the sky, the Andromeda galaxy, its disk, which it will. It's going to be pretty amazing. But the first closed passage will happen 2 billion years from now. Of course, by then, we know now that life on Earth will be long, long gone. About 1 billion years from now will be the end of life on Earth. The collision, the merger of these two galaxies will take place something less than 5 billion years from now. Maybe about 4.5 billion years from now, approximately. And it'll be made plausible, not because of all the cool stuff that we look at and want to talk about in our telescopes and write books about and stuff like that, that is made of glowing baryonic normal matter, stars, planets, and nebulae, and so on and so forth. But the dark matter halos of these galaxies. Galaxies have dark matter halos that are vastly larger than their bright disks. And so when these dark matter halos come together and interact, that will actually help facilitate the energy and create that merger that will happen eventually between the two galaxies. When the galaxies are separated by about 300,000 light years, the dark matter halos will begin to accelerate the process. So we'll end up with a large chaotic galaxy. In fact, this is how you make elliptical galaxies in the universe. Galaxies are made as spinning dynamical disks, as spirals or something close to it. And elliptical galaxies, big ball-like masses, chaotic masses, happen by collisions. So maybe the Milky Way and Andromeda will look something like Centaurus A, if you've been in the southern sky or seen it online, is a big spherical mess that's undergoing a re-energized bunch of star formation because two galaxies slammed head on, came together, and a whole lot of energy went into these central black holes that merged in this galaxy, and that created an enormous chain reaction of new star formation. Wow. That's something like maybe what will happen with our galaxy and Andromeda, from the gravitational collapse of gas clouds that will then, like the nebulae, that will then be recycled. But there won't be many collisions of stars in this big pileup, because there's so much space in galaxies. There is so much space between even the nearest stars. If you had our sun the size of a pea sitting in London on a little stand, then Alpha and Proxima Centauri system would be even smaller yet and would be in Paris. So most of these galaxies consist of empty space, and there won't be a lot of head-on collisions with stars, except for the central hubs near the centers of these galaxies. So it's kind of a reminder of what we see, this beautiful static universe. We don't see a lot of change in the night sky. We're seeing really one frame of the celestial movie that's going on and on and on. And poor us, we get to hang out and talk, with each other about our love of the universe and understanding it and so on. But we really see sort of one celestial frame for the most part in our lifetimes. Only things that are really close to us do we see them change a lot. But the universe is really a dynamic place everywhere, and we don't see much of that change because the distances are so huge. So eventually there will be a merger. We will have a super galaxy in the center of our local group. There'll be a huge bursts of star formation, and maybe we'll have some descendants somewhere who will take this all in and remember our generation when we first were aware of this and started to talk about it. So Scott, thank you very much for having me.
Yeah, hopefully they keep this, your talk today, and they can replay it back then.
Well, I don't know about that.
At that time. That's right. David Eicher, that's right, 3 billion years from now. Anyways, one of the things that occurred to me, I don't know much at all about dark matter, except that it's something that I am starting to learn how it is an intrinsic part of galaxy formation. But I'm wondering, as these two galaxies come together and the dark matter meets, would it be a little bit like how trees, you have the tree root system, you have a forest, okay? And what is it? And they've discovered that amongst trees in a forest that there's a fungus actually communicates between the trees, and then they will, through that communication, they'll start to share nutrients and decide which trees that they're going to give more nutrients to. I'm very curious if dark matter might behave in a similar way between galaxies.
Well, I think in an analogous way, yeah, because in some sense, it kind of fosters the communication of the merger to come, and it absorbs and passes on some of the energy that facilitates things to slow down and merge the normal bright matter the way that will happen. And again, we know that dark matter exists. In the 1930s, it was the irascible and sometimes thought to be crazy Fritz Zwicky who proposed the existence of dark matter, and so did Jan Oort, by the way, back then.
Okay.
To explain what must be going on, and that it must be a substantial form of matter. But of course, it was the 1970s when Vera Rubin and Kent Ford and their collaborators at Carnegie, but chiefly Vera, found the real evidence for the existence of dark matter, and that to even explain the rotation curves of galaxies, there had to be a majority of the matter. This is the most of the matter in the universe. Now, we're not talking about energy here. which is an interconvertible form. Energy and mass are interconvertible forms of the same thing, of course, as Albert Einstein taught us. But just of the matter, don't count dark energy for a moment here.
Okay.
But dark matter is much, much more matter in the universe than the normal so-called baryonic matter, bright stuff we see. So yeah, I think there is a sort of and by the way, you know, you can win yourself a Nobel Prize by determining what dark matter is still, as well as dark energy. In the 1970s, astronomers proposed that the likely candidate is a subatomic particle, the axion. It's never been discovered, an axion, as yet, with all the particle accelerators. So we still don't know what dark matter consists of. But yes, I think to answer your question, sorry, without going on too long,
interesting.
I think that, yeah, there's an analogy there that the dark matter halo does some of the facilitating, if you will, and communication, even if you will, about merging the bright stuff that comes together and creates this big elliptical mess.
Wow. Excellent. Excellent. That's great. It's making my head spin. It is. So it's wonderful. It's wonderful. Well, do we have, let's see. I had asked Richard Grace to share some of his images in between talks here. Our next talk will be Living in the Stars. But I was curious what you might have to share with us today, Richard.
Okay, let's see. This screen.
There you go.
Okay, we should have a black screen, which is the scope currently. Let me see. Did that just pop up on there? Yes, it did. Okay, I see it. We got the Orion Nebula before scope modification of putting in a larger elliptical secondary mirror. And hopefully after the clouds clear out a little bit, I'm seeing them on my guide scope. I'm seeing a couple stars come through every now and then. So I may run outside to polar align, but everything else is set up. And let me stop that one real fast here, because after...
What will you try to image tonight if it clears off?
Well, I'm definitely going to go for Orion first. Let's see here. David was just talking about Andromeda, you know, running into us and some stuff here. And where is it? Here we go. This is good enough. And Triangulum, the three parts of our three galaxies in our local group. I figured I'd show those real fast, and hopefully I can get some sort of image up on this screen here next time you come back around to me.
Okay. All right. Sounds good.
Cool.
Sounds good. Okay. So our next speaker is our youngest lecturer. This is Libby of Libby in the Stars. And Libby, do you know how many talks you've given so far?
Well, I think I joined the Star Party when we were at the 8th Global Star Party, so that would have been 24 Global Star Parties.
Okay. So we're not even quite halfway into all the talks that you wanted to give. So that's great. That's great. And do you feel you've got a lot of experience now giving lectures with this group? How do you feel so far about it?
It's just now a group of friends. It used to be like business, and like I was scared to get on. And I know the first talk I did on Mercury, I could tell I was very nervous and I wasn't able to talk a lot, but now I just see those friends and people that I'm with every week, and maybe even on the daytime show, it's a lot of people I know, and it's like a lot of friends.
That's what our community is.
you don't make any friends during virtual school because you don't communicate at all. So it's like it's just this astronomy friends that I get to talk with over the phone and on Zoom meetings. It's just a lot easier to just meet over Zoom meetings, and it's just very nice to like. I know my first talk I did, everyone could tell I was very nervous. I actually
All of us have been nervous. All of us
Yeah.
have been nervous giving a talk. So it's normal.
I actually wrote like a whole maybe 5-page documentation on Mercury when I did that talk. But I guess I was just so nervous. I just just only did a little bit. I still have all the information, and I hope one day I can go back and
You can do it again. You can do it again. That's no problem. You know, as you get older and even more experience in speaking and learn more about astronomy, Libby, your lectures will become more and more compelling, more interesting. You know, there's always new stuff being discovered all the time about all these things. So, you know, that's updating your material will be great. It'll be refreshing to you, and it'll be great nourishment for people who are interested to know more about our solar system and the universe, as you've been bringing up, you know, each global star party. So, and what is your talk going to be about today?
I decided to talk a little bit about the Elephant Trunk Nebula.
The Elephant Trunk Nebula. Okay, great.
I wanted to connect back to you have to have imagination to discover things. I was looking at this nebula, and a lot of people called it by a special serial number for the nebula, as the professional name for it is IC1396, which that's kind of boring. The person who just you have to have imagination when you're discovering things. And I just kind of imagine the astronomer all back then, discovering this nebula and naming it Elephant Trunk Nebula. It's just a lot. It's just seeing some of the names of the nebulas. You can tell there's a lot of information, imagination, and there's a reason behind it. And it's just a lot of work that goes into discovering nebulas, because you have to have that imagination, like David was saying. And I just always thought it was funny seeing the name of this nebula, because it just
can you see when you look at it? Do you see the elephant trunk yourself?
Yeah, I saw it. If you can look at the edges of the clouds where it's a little bit harder, and you can see the outline of it. And I think imagination is good when you're doing astronomy again, because the most of the names of nebulas are kind of funny, Sometimes they're no one wants to be oh my gosh, I found a nebula. Its name is IC1396. They don't want to be like that. They don't want to be I found the Elephant Trunk Nebula. And that's the thing with a lot of the nebula's names, is that they all have imagination behind the discovering. Whoever discovered it, they don't care how old they are. They all had imagination behind the names of the nebula. And recently I've been trying to upgrade my telescope so that I'm able to control it from inside my house, because currently we are piled up with snow, and I've been trying to upgrade it where I don't have to go outside and be freezing cold, because you could probably get frostbite, as the news said, in less than 30 minutes. And that would be very dangerous, and I'm not going to risk that. And so I've been learning about degrees and stuff, and just how we were talking about the Andromeda galaxy in a couple billion years stretching across the sky. I've been learning about degrees of the sky and star maps, and I have this one software on my iPad that I use. My iPad is the thing that I use for most of my astronomy stuff. I don't have anything technical. I just have a little iPad, and hopefully a computer, but I have a mobile star app, and it's a star map. It's not a lot, but it's I've been learning about degrees, where you can like this nebula is like, let's just say, like imaginary, but like 10 degrees across the sky. And I was trying to like map the sky. I was thinking about that one night in astronomy. What if we mapped the sky? And it turns out that was already done for me. I didn't need to do any work. and it's
But they're
just
still doing it, you know, they're
yeah,
still mapping the sky.
you know, star maps are still being produced, you know, everywhere. Virtual star maps, which is what I have, and it's just a lot easier. I know it's mathematic to think about degrees and stuff when you're trying to find stuff in the sky. But if you just take a second as an astronomer to find where it is, it's just like there for you. It's done. And I was kind of ecstatic that like super excited that like astronomers out there have already like made a like grid for the night sky and made it so easy to find it and know the times. And it's just so much easier to find it. And I'd like to find this nebula one day. I haven't found it with my telescope yet because he's been covered in 1 foot of snow. I would love to tonight, but no. But it stretches 5 degrees across the sky in the constellation Cepheus. And Cepheus is the 27th largest constellation in the sky. And Orion, that telescope, well, not telescope, constellation in the sky, it's a pretty good size. I mean, it's probably one of the biggest constellations in the sky. And I know 27 out of like all the constellations in the sky, there's a ton of them all over. It doesn't seem like the largest, but it will be because all the constellations are pretty much the same size, but just a tiny bit smaller by. They're just an itty bitty bit smaller by like a couple degrees when you're mapping the sky. And I was looking at the nebula in the picture, looking at like identifying that it is an elephant trunk with like imagination and stuff, because I was going to talk a little bit about that as I did. And
let me ask you a question, Libby. How important is imagination to you as you're starting to learn more and more about astronomy and science?
When I was little, I used to I was like, there's this one kid in my grade who was like, you can't do that. You can't become an astronomer. And I always had imagination. I was like, I can go to space on my own rocket ship if I want to. And imagination, there's no limits to it, you know. But it's just dangerously like, I mean, if you're gonna say you're gonna go outside without a spacesuit, like outside your capsule, I think you'll be fine. I mean, that's where imagination should stop. You should stop there. But I think imagination has no limits, you know.
That's true.
The person who discovered it, sometimes if I'm like just star hopping randomly across the sky, if I'm just like don't know what to look at, you don't know what you're looking at. And you know, imagination can be, half of you can be like, oh, I didn't discover anything, probably discovered like a couple million years ago or whatever in the Renaissance. And but also another half of you is saying like, you discovered something, oh my gosh, may not be a discovery for you, well, may not be a discovery for like the whole world, but it may be for you, your first.
It is for you.
Yeah, you've never seen it. It's that second. You're seeing it real life, in life. That's you. That's your hard work that you put into seeing it. And it doesn't even care if it's like a discovery, unless it's a discovery for a world. I mean, that would be important. If you just found another planet in their solar system and it was just like, nah, it's nothing. So you have to know that there's like a whole ton, like our universe is never ending. Like there's always stuff to explore. And that's why I like to say when people ask me, why do you like doing astronomy? That's because, and I always say, I like doing it because it's like never ending, because there's always so much to explore and it never ends. It's like a generation long thing, like a million generations till life is gone. It's something that, takes imagination to know that you discovered something and that's your work. And I know I was looking at the photo back on the trunk elephant trunk nebula. Yeah. And I saw these stars, and I was like, I bet that's like a million stars. And I was like, oh, it's only 250 were identified. I was like, only 250? I was like, I see a million. And then I realized, oh, wait, that's just only 250 have names that have been discovered.
That's
And
right.
to make that's like easier, if you just look far into the nebula, there's a million stars in the nebula, even more maybe. I know there's star counters that people use. I don't have that technology, but there could be a million stars and only 250 of them were found. You can discover like 100 of them easily. Just like mark it off your list, and then you can be like legendary for exploring a lot of stuff and making discoveries. And you can even name it yourself. There's a million stars to name out there. You can have your own imagination to name it whatever you want. NASA has no limits for whatever you want to name a star. You can name it like a bunch of like random numbers and stuff to make people complicated. But it's like
getting it published might be a little tougher.
Yeah.
But you can certainly make your own. That's very true. Libby, I think that the point that you're making about imagination is very important, because scientists, cosmologists, astrophysicists, astronomers, engineers, they all use imagination to try to figure out how to accomplish a job, or to develop the next theories, or to do some of the more, what would be seemingly impossible to do. If you don't have the imagination, you can never get there. So I would say keeping your imagination rich and vivid is very important. And at listening to you now give this talk, I can see the educator in you. And I think, when you're of the age to do that, you're going to be quite good at it. What else would you say about the Elephant Trunk Nebula that you feel is so compelling to you?
I know how you're talking about like life will be over by the time like the Andromeda galaxy stretches over the sky. But it's like amazing to be so close to like everything, like the moon and stuff. We're so close to that. The sun, like that, we're not too close to that, but it's huge enough to like look at it. And I think it's just very easy to go outside. Like, don't even have to have a telescope, binoculars, and like just even in your eyes. And the Elephant Trunk Nebula is 20 light years long. I mean, it like 5 degrees in our sky and 20 light years long. You should be able to take binoculars. I mean, you won't be able to see it with your eyes, but just take binoculars and you could be able to see the Elephant Trunk Nebula. And I think that imagination has to keep on going for you to be able to go outside and be able to, think like, I'm going to find the Elephant Trunk Nebula and with my binoculars. You don't even have to have a telescope. It's just a good thing to like even if you're not interested in astronomy and you're just doing whatever, like even you're just like don't even like just binoculars, don't even have to have a telescope, doesn't even have to be good. It's just I'm kind of sad that life will be over in 3 billion years on Earth and that we won't be able to, see the Andromeda galaxy. But as our generation is so far, we have to explore it with, I mean, our technology is advanced for our generation. I mean, we can really do anything with, I mean, NASA, their technology is like probably the most advanced on like planet Earth. And I think that it's important to look at this stuff before, you know, we go, Earth goes. It just takes imagination to look up at the night sky and discover.
Thank you, Libby.
Thank you.
Yep. Now I'm excited to go out with my pair of binoculars and go look at the Elephant Trunk Nebula. So there you go. It's magnitude 3.5. Some people have seen it with the naked eye. Okay, so I think you'd have to have real dark, transparent skies to see it. So Libby, maybe you can get your parents to take you to the Buffalo River or something where it's we've got Bortle 2 skies there, and maybe you can spot it with your eyes, and then you can try some binoculars, and then take that Dobsonian with you and get a good look. So thank you, Libby. That's great. Okay, we are going to transition here. Our next person up is, we're running a little bit quicker than we do on some of our star parties, but that's okay. Our next speaker is Chuck Allen from the Astronomical League, and he will read the door prize answers from the prior Global Star Party and questions for this one. Your answers will be sent to Explore Alliance. I'll go ahead and put this into the chat.
It's on each slide too.
Oh, good. Okay. That's perfect. Explore Alliance at explorescientific.com. There we go. All right. I'm going to turn it over to you, Chuck. Thank you.
My audio still okay?
It's perfect.
Okay, great.
Maybe
Hello,
the best
everyone.
it's been.
I had a little glitch earlier. Sorry.
Yeah, that's good.
Good evening, everyone. I would like to begin by sharing screen here and show you something that came up a few moments ago when Dave Eicher was giving his wonderful talk on Cloud Tombaugh.
Yeah.
And hang on. Okay. This is the blink comparator that Clyde used to detect Pluto, and I just thought I would show your audience a brief set of images to show what he would have seen as he looked through the blink comparator. What he did was take plates of the sky, those glass plates that David Eicher referred to, about 3 days apart, and then he would know roughly how far a planet in the estimated location beyond Neptune would have moved in 3 days' time, which would be most likely on the same plate. And so here is what he would have seen as he blinked back and forth between those two photographs.
And that is Pluto, I suppose.
That is, in fact, Pluto, yes. And this is just a 1 day apart image. First time I observed it, it was inside a little quadrangle of stars, and the next night it was just outside it. So it's something you can observe move from night to night if you can locate it. It's quite a project to plot a course to find Pluto, and you have to have good charts and invert them if you're using an SCT and do all kinds of work, but it is something interesting to do and fun to do. Okay, moving on, I would like to start with the warnings we always give with our door prizes, and I think it's a good warning to give in any program on astronomy, and that has to do with solar observing and the safety that needs to be observed when doing so. You should never, ever observe the sun without professionally made solar filters that include energy rejection filters that are mounted at the front end of the telescope to keep all of that light and heat from entering the telescope to begin with. Never use any type of welder's glass eyepiece filter that fits just over the eyepiece. Those can explode in the heat. I've not seen any of those sold in the last several decades, but they used to be back in the 60s.
Mm-hmm.
be aware that just because you go to a star party and look through someone's sophisticated telescope with these filters does not mean that all telescopes are safe to point at the sun. The people who set up these telescopes at Astronomy Society outings have the professionally made equipment. It's not on most telescopes, so make sure that before you ever look at the sun through a telescope that you're in the hands of someone who's skilled with this and has the proper equipment. Remember that eclipse glasses should be certified, and there are sources of information the Astronomical League can provide you about how to determine whether, in fact, what you have purchased is a knockoff or where you can purchase actually certified eclipse glasses. And they're only for use naked eye observing. You do not use eclipse glasses and then look through a telescope or binoculars. Absolutely not. It's best to always consult with knowledgeable solar observers in a local astronomy or club before you ever attempt to observe the sun. And these are just warnings to protect you. And I'd like to add one other thing. Since we have a lot of cold weather in the United States now, people who go observing sometimes get in their cars and turn on the heat and try to warm up. This can be dangerous. Carbon monoxide, in some cases, if you have a leaky exhaust system, can leak into the car and they'll find you in the morning. You don't want that to happen. These little devices insert in cigarette lighters. They are CO detectors for car charge for cars. They cost about $29, and that may be worth your life. They can detect, they make an audible alarm if they detect carbon monoxide, and they also read out parts per million on a little display on the face. And you can also use it as a charger for your phone. So just a little safety for cold weather. Now let's look at the questions from February 4th. The first question is, how do we know black holes exist when no light can ever leave them? Well, there are two primary ways. One are X-rays emitted by gases that are accelerated in a disk around the black hole. And second, stars are often seen in tight, rapid orbits around unseen gravitational sources, such as at the center of the Milky Way. These are stars that just whip around something unseen, and that cannot happen unless it's something incredibly massive. And the winner on this question was John Pinto. And you see, by the way, down here on each slide, you'll see where to send your answers for tonight's questions once we get to them. The second question, when the shape of the moon is like the letter D, why is the half of the moon's disk dark? Well, the answer is we're seeing the moon at nearly a 90-degree angle to the sun. So half of the disk that is visible to us is not illuminated by the sun. And the best answer on this question was given by John Persicilli, and congratulations to him. Finally, question 3, who discovered the universal law of gravitation? And that was, of course, Sir Isaac Newton. And the winner on that question was John Cathy Adler. Okay,
great.
Moving on now to our questions for tonight. And the first one is, averaged over time, what planet spends the most time, I should have said most time, as the closest planet to Earth than any other? That's averaged over time. Think in terms of a year or more, or several years even. What planet spends more time as the closest planet to Earth than any other? Okay. Question 2, who first postulated an inflationary origin to the universe in which it expanded by a factor of 10 to the 78th power times in less than an undecillionth of a second?
Undecillionth.
Now, 1/10 undecillionth. 10 to the minus 37 seconds. Okay. And there's send your answers to the address down below here. And the third question, what constellation covers more north-south degrees of the sky declination than any other constellation? Okay.
Good questions.
That's it.
Good questions. I will add to your point about safe solar observing. We had a contact customer service. This was during the 2017 total eclipse.
Yes.
And we had been we were in the business of marketing eclipse glasses, and apparently this fairly experienced amateur astronomer contacted us to make sure it was going to be okay to look through his telescopes with his eclipse glasses on at the sun. And so that prompted me to make a video. It's actually my most watched video. It's been watched over 100,000 times, but it shows what happens when you have eclipse glasses at the point of the eyepiece. What happens is that the sun burns a hole through the eyepiece like a laser, okay? It is, you know, you only want to be using over the lens solar filtration. And like Chuck said, it has to be the right stuff, and you have to do it the right way. You know, this is, it is amazing to observe the sun through a telescope, but you really need to study up on it and get great advice from experts. So just want to put that out there. I could just imagine this guy, you know, so yes.
Scott, could I add something to Chuck's excellent demonstration of the blink comparator and
sure.
with Clyde? For a long, long time, the blink comparator was at the Smithsonian, and the A plate of the two glass plates is still there, but it has recently come back to Lowell. So in the future here, when it is fixed up and Lowell is going to build a huge new museum and everything, but the actual blink comparator that Clyde used will be on display in the relatively near future, again at Lowell Observatory.
And may I add, when I was at Flagstaff in 2019, it was at the Smithsonian, and when I was at the Smithsonian later, it was back in Flagstaff. So I still haven't seen it personally.
If you ever want to see, you know, your life flash before your eyes, I've done this several times over the years. You can get down to the plate vault with Brian Skiff, who will, without even looking one direction or the other, pull the Pluto B plate out, lift it out of its jacket and hold it there, you know, and you thought, my God, you know, if this thing falls to the floor, it's going to change the course of astronomical history, you know, but Brian is fearless with that.
Oh my goodness. Well, he's probably handled the plate so much, you know, that's great.
And you might want to emphasize, Dave, you might want to emphasize how cold it was in that observatory during most of the time in the winter when he was doing this work.
Oh my God, yeah. Very cold. And I just did a different thing talking a bit about Clyde a few days ago for Lowell and you know, rereads. And, you know, Clyde was really a master. You know, he prepped that telescope before he used it every night he could, checking all the adjustments, checking and making sure everything was tight, looking at a high magnification guide star before anything was going on. Of course, as you know, we talked about a little while ago here, the plate had to be curved very slightly, the glass plate for the Pluto camera, as well as the Schmitz out at Palomar. So that was a 14 by 17 inch plate. It was an enormously hard thing. And it kind of reminds me, in a more modern age, he kind of prepped the system so thoroughly and uniformly, almost like a pilot would prepare a modern commercial plane before you take it out. You know, he was so meticulous. It was quite something. But thanks, Chuck, for the great blinking demonstration.
You're welcome.
I'm curious also, that now that we also have you on the show, David, the iHeart Pluto Festival started on the 13th, is that correct? So
yeah, Alan Stern gave a talk about why Pluto is a planet and should forever be a planet. So take that, Mike Brown. And that led off the festival. And then we had a group of us, including Clyde's son, Al, the following night talking about what Clyde was like, you know, and reminiscing about him. And it goes on for several days yet. And we're going to have another panel on the 18th here talking about Pluto with Alan and with Al Tombaugh and with some others too.
Okay. All right. So to see this festival that's still going on, you will go to iHeartPluto.org.
Exactly right. And I think that will drive you to Lowell Observatory's YouTube channel so that you can watch things live or later on as well. Yeah, very analogously to what you're doing, Scott.
Oh, good, good. So their schedule, let's see, this is the 16th. So today they had Dr. Will Grundy on.
New Horizons team.
New Horizons, yeah. And I guess he's a planetary scientist. And then tomorrow, a tour, it says an NOFS tour with special welcome by Jim and Charlene Christie. So that would be...
So Jim Christie, of course, discovered Charon and at the across town at the Naval Observatory and named Charon, not a hard Greek K-C-H, but Charon after his wife Charlene, which is why it has this soft C-H. Yeah.
Oh, nice. Nice.
Yeah.
And then Dr. Dan Durda is on with Marilyn Flynn and Ron Miller on the 17th. The 18th, they have Victoria Gurgis. She's an educator at Lowell Observatory. Kevin Schindler, who's the historian there at Lowell that was on our show. He'll be on the 18th as well. And then let's see. And then there's an open discussion. Are you going to be in that program on the 18th, David?
Yeah. Yeah.
Okay. Very good. Very good. I highly recommend it. This is going to be a great thing. You don't want to miss the landing on Mars, but you do want to watch parts of this as well. And I think that we are going, normally we have a show that starts about 4 o'clock Central, but I think we're going to forego that because there's going to be a lot on the Mars Perseverance landing. So, well, that's great. At this point, I'm thinking that we might jump over to one of the astronomers. Does anyone have a live view through their telescope before we go to a 10-minute break?
I just got one, but it's not very exciting, but I'll show it anyway.
All right, well, let's see it.
All right, here we have Orion at about 2 seconds, and it should be showing my guiding, which is currently calibrating because I flipped my camera upside down, so I figured I'd let it redo that. So I'm not going to get anything pretty just yet, but we got sky. All right.
And why don't you describe your setup a little bit? What kind of scope, mount, camera setup are you using tonight?
All right. Well, let's see. The main visual camera is a ZWO 2600, which is fairly new, but I've hardly got to use it because of the weather. That is mounted to an Explore Scientific David Levy Comet Hunter. And I just put a new Ostahowski 2.6 inch quartz elliptical secondary mirror in it, and it looks to be illuminating the sensor quite well. So this is making me very happy. I can't wait to see how it works out once we process something a little bit. And we're using the Carbon ED80 as a guide scope with a ZWO 183 cooled on the back of it. And that's all riding on a Skywatcher EQ6R with some upgraded rings and dovetails and clamps and stuff like that. And we got about 37 pounds of weights on it tonight.
Okay. All right. So we're going to take a 10-minute break. After the break, we'll have Cesar Brolo on from Argentina. He's got a presentation he'd like to make. Rodrigo Zeleda is down in La Serena, Chile. He's standing by right now. Molly Wakeling, astrophotographer Molly Wakeling in Los Angeles will be, actually, she's not in Los Angeles, she's in the Bay Area, will be coming on later. And we have guests that we think will be joining us. I have invited people from our daily show, and also I will put the Zoom link so that you could go into our waiting room and have Kent Martz check all your systems and everything and make sure you're all set to go for contributing to the Global Star Party. So we'll see you in about 10 minutes, and hope you're enjoying it so far. I know I am, so here we go. It's time for me to finish my sandwich. Okay, it looks like our our 10-minute segment went a little long there. So anyhow, I wanted to bring up our next guest here, which will be Cesar Brolo. Cesar.
Hi, how are you?
Yes, great, great. So how's the weather down there in Argentina right now?
Yes, about the weather, we are having cloudy skies. Is most of the middle of the summer, and we had a week very rainy, cloudy. But 1 week ago, we had an excellent weather and very dry weather without humidity, and the skies was more had more transparency, and but in this well, the good weather is coming. It's like how do you say, like a Murphy law in astronomy, when you have the clear skies are coming with the crescent moon, and we say why, but we could enjoy we could enjoy a third party, very nice third party, one week ago on Saturday 6, past Saturday 6, in the area where my company, where I work, in my company, Saraco.
Yes.
We are being a sponsor for astronomy association that is Bella Vista al Cosmos, and Bella Vista al Cosmos is working in the restoration of the San Miguel Solar Observatory. That is a very
you gave a presentation on that before,
yes, you remember, yes. And we are working. I'm really concerned in this, and I am being part of Bella Vista al Cosmos. Sometimes I can't be only a sponsor every time. I'm going to be part. I'm going to be more concerned about the different projects of our clients, and that it's impossible to say no every time that some people tell me, okay, we can restore this, or ever I going to be part of this project. And really I enjoyed this because it's a part where sometimes you don't need the business of this. If not, you need to be a part to make something different. This is incredible because it's a complex of astronomy that in the first decades of 20th century, this observatory was very important for solar investigations, and I show in the past the presentation of where have the tower, Celostato, have 3 different telescopes for solar being watching or photography. In the past, they have a Liot from Belgium, from Belgium is the name of the country. That is a Liot spectrometer in H alpha. Well, it's a huge amount of instruments to repair, to restore, and really we are I say we because actually I as part of Bella Vista El Cosmos, I am inside the association because I don't say no. I don't know how to say no.
You are a yes man.
Yes, yes. Maybe you have the same problems sometimes, but
Yes.
really we love to say yes, and this is why. Of course, that is a pleasure for me, and it is something that really we enjoy to be a part. Really, I have if you like. Well, we made the first star party in the night. The first inside the complex. The first meet was in the eclipse in December 14. And of course, that do you remember? I was not in the complex. If not, I was with the association in Valcheta. The people can found the accidented very freezing transmission of the eclipse from Patagonia.
Yes.
And the people that don't trip to the Patagonia, don't want to the Patagonia, make a meeting with the lecturers of physics, people, in few numbers, no more than 100, to make the partial eclipse in the observatory from Buenos Aires, from San Miguel exactly, because San Miguel is at maybe no more than 30 kilometers from Buenos Aires city, in the west side. And let me show you something about we have I have, sorry, a presentation.
Yes.
If this can work, because I don't know why. Okay. Well, okay, I'll share the screen.
There you go.
Okay, and check if work. You can see it?
Yes, I see it.
Okay. Okay. Well, yes, a third party with mask and social distance. This is interesting because this was our first star party from more than 1 year, because the pandemic situation, made impossible to make something with people. Really, we make in Argentina the same like global third party by Zoom, and in this occasion we could make a star party with real people, because the majority of the government of the San Miguel, they support all project, and especially they bring us the opportunity to make a 100 people limit and start party. Was interesting because was a start party with masks, with social distance, and worked really fine, really good. This is the program that we made. We started at 7 p.m. With we have the visit of different people, different lecturers or doctors in physics or specialists in different things. For example, we receive Daniel Cabezas about origin of chemical elements and solar evolution and supernovas. Dr. Mariano Poción, he told us he's part of our group, El Magnetismo del Sol, the magnetic field of the sun is a special thing about us because the group is, or the observatory is a solar observatory. Mariano actually worked in the IAFE. It's a very important place where the people study physics and astronomy and investigate a lot of different things in Buenos Aires, Argentina. Daniel Cabezas came from another association in San Miguel that worked for many years in teaching astronomy, that is NDIAS. Nicolas Balbi he talked about archaeoastronomy. He's a very specialist. Nicolas Balbi is an archaeologist, but he knows a lot of astronomy, and is a specialist to mix archaeology and astronomy. And he told about the calendar, about antique Rome, and he knows a lot about Mayas and Aztecas calendars and how the ancient worlds take the measures of astronomy. And when it's a great helping when Nicolas Balbi are in Buenos Aires, because normally he work in Rome, Italy, because they are working, in different places. And when we have in the group in Villa Vista del Cosmos, Nicolas, we are really lucky because he worked a lot, especially because in the recovering and restoring of the observatory, he have a different vision, and he know more about how to organize a lot of different materials. And here working for us a very huge work recovering information about the observatory, because the observatory is from the first times of 20th century, and we are all the time we are searching and finding a lot of information. And Nicolas Balbi know how work and recover and organize this information. After Daniel Flores, he worked about amateur astronomy, how to start his from NDS 2, and Jose Fabro told us about recovering and working with the radio telescope, because the observatory have a radio telescope too. It's very interesting because it's incredible. The complex is so complete, and if we can take the right way about how recovering, and fortunately we have how do you say, how we have the support, sorry, of the people from the government of San Miguel is very important, and you know, I think that the project is going in a very good way. At last, Rafael Girola, Santiago Mayese, they told us about Nebulosa Orion, Orion Nebula, sorry, in English, was an object that we project in a live. Normally, my work in third parties is put a telescope and project in live. Of course, image of a nebula, galaxies, you know, and it's like something like especially in this time where you cannot show to the people, for every people going to the telescopes and sharing telescope, especially we are using more the project in a live, in a screen, nebulas, and because the people can see without move from their places. And we are the most important thing was take the social distance for the people. You know, it's not easy. Well, this is a picture of the beginning of the safari. I'm sorry, I told that Rafael Girola and especially Santiago Mayese. Santiago Mayese is actually the director of the Bella Vista El Cosmos, and he make a huge effort to make this project ahead.
How many people were at this particular star party?
In this
limitations that you have.
Limitation 100 people. Yes, we complete. In this picture, you have the first time of the star party, the beginning. In 2 hours later, we had the complete number of this. And in this picture, you have maybe 30, 40 people, but we completed the 100, complete assistance. It's impossible to make something for more people because, you know, the rules now are very, very clear about this in every word. This is the typical time in the early star party to work with equipment, to arm. Really, this was something that for me was something that I missed a lot of time, and really for everyone. And really, we are concerned about the every people use their own telescopes. You know, you can share telescope. You can really move a lot from your place, and we are watching all time how the people go into the moving around the third party with the most care about this.
Yes.
But fortunately, work very, very well. These guys, Javi and Fernando, they work a lot inside the group of Bella Vista El Cosmos, are very, very important part. This men, Javi and Fernando Ricardini. The telescope that we are working again with this is the double telescope that is around 6 inches refractor with a solar shield. That the solar filter is from a stone, is normally onyx stone.
Oh wow!
Yes, it's really the first time that I watched this, I say, okay, it's broken. No, it's not broken, because when I searched what kind of filter is.
Okay.
Is a really a stone polished in parallel and really flat quality.
Oh, wow. I've never
1
heard of
inches.
such a filter.
Yes, it's lovely. It's around 1 inch thick. It's amazing. It's amazing filter, and the quality of the image is amazing, really. And this telescope work really with a clock system. Don't have motors. Our idea is, without loss, the clock system is put a step-by-step motor, and but without lose the clock system, because we can make like a clone system where you can use the step motors of the clock original system.
Okay.
And we started to use the telescope to take a picture of Orion Nebula.
Okay.
I try using the old clock system, for a telescope from the 1920s, 100 years, yes, with the old clock system that we recover, repair, clean,
This clock system is it weight driven? Is it use a weight to?
Yes, do you have in the
real
same column? Sure. And here, it's the old system that you have like an umbrella with two small spheres. It's very very common to watch in the telescope from this year. For the of course that this have a horrible periodic error, and but we can get pictures from Orion with a telescope for 100-old telescope, and really we felt very well about this, and think that that this telescope was made for only to use for solar image, and with very short exposures. But our idea is to use every time more. They don't work properly now. We have some problems in the movements, but I think that this telescope is working in 80% actually. We have the first one telescope to use 10%. I say maybe the function of the telescopes is something like to use for night astronomy, like this, because we say, okay, we don't have tracking with more time than 5 seconds now actually, but we can put a motor. I can talk with Jerry Hubbell or somebody that I can have ideas. Yes, it's with a guider system, no problem. Because it's do you have a very good material to work, and this is the first telescope of a complex. It's the small one. I think that we have Celostato. We have it's huge, the quantity of instrument to repair and recover. But this one, the first, is working actually. We can put the reflex. We make the all new system for reflex camera, for CCD, for planetary cameras, for 2 inches for the diagonals, Explorer Scientific eyepiece, of course. We're preparing all. This is ready. We are going to use this completely, this telescope.
Great. Wonderful.
Yeah. Another picture of the star party in the beginning. Very interesting the talks because the people enjoy things in live, because actually it's impossible to think in a live session about astronomy. Okay, we take the risk of make something small work properly. The people understood that they could have the problems if not they had the care herself, the but this was excellent. Here's Mariano Poción talking about the sun, about the magnetic field of the sun. This Mariano is a doctor in physics. He's a great member of our group. And this is Nicolás Balbi, the archaeologist. Is a genius, this guy. We could make talks without Zoom the first time.
Yeah.
Yeah, but we are preparing another star party in the place, but with less people, transmitting by Zoom, maybe March.
Very good.
Yeah. But we found a little girl, like maybe is the next Livy in the stars, because she was a genius. The best question about astronomy, archaeology. My face when this girl asked me about, the question was, I can't believe that the right question, the best. Well, really, we enjoyed this. It's the best things in star parties. Well, all people with masks. Yeah. You can see an excellent telescope for in the beginning. The 90 millimeters refractor that we use a lot of in the last eclipse in San Juan.
Yes.
Not the last, the last was in Patagonia.
Nice telescope there.
Nice telescope. Yes. Fortunately, we are watching more Explore Scientific in our star parties, and the people they bring their telescope for to the people have the like when you have a liberty with a jailed animals. I felt the same. I can go with my telescope, of course. Yes.
Sure.
Really, we enjoy this because really we was desperate to go to a star party in a real place. Was nice. The people enjoy this. Another picture of this telescope, and the celostato you have in the background. Here is the area where the celostato is, and this is the tower.
Okay. We
make Santiago Mayese, the director of Bella Vista del Cosmos, accompanying for the people to the wide visit, for the installations.
Sure.
It was very interesting. And this guy this guy started, this is Fernando Ricardini. He started to make astrophotography in March. Now it's a genius. He started in March of 2020 and now make an excellent star parties. Explains something to another guy about astrophotography. And
What a
this is the
wonderful place. It's a wonderful place to have a
yes, yes, yes. I thought first of all in Stefan, where you have the domes and the historical domes, and this is a place. I think that this time was only 100 people, but the place is the sky is bad because it's the same sky that in suburban area, but the people enjoy the historic place, the historic environment is about this. It's amazing. It's amazing, really. And you have horizon, and you have, outside the field, you have homes, and it's a suburban area. It's not the field, but when you go to the place, it's magic because you think that you are in the rural areas or. But it's really nice place. In 1920 was a really very dark, had really dark skies. But now, of course, that is a suburban skies. But the place is amazing. It's really amazing, and the people enjoy really a lot. Use their telescopes. Something that was nice was that the government of San Miguel, they put people to illuminate very soft with LEDs in different colors, the domes, the different areas, and this was very nice. It was magic. If you are in a really dark area, you really hit this. It's impossible to use, but like when you are in a suburban skies, you don't have problem to use a little of light to make something of light in the domes. But of course that they turn off in the middle of the night to take some pictures.
Sure.
Here's me watching with the people about a talk about telescope with the telescope in a live.
Like
yes, reflectors for people that never use telescopes. But we have the two different type of people that coming to use their telescope: amateur astronomers, or people that start the first time to know about astronomy. They are very interested, and they love to listen about the first impressions about astronomy, telescopes. And this is very, very nice, very important to talk with these people. Well, in the night we use the celostat wall to project something about the history of the globe, the history, pictures of the history of the.
Wow, that's great.
We are collect of the San Miguel Observatory from the history. Actually, Santiago Mayese make another group to in Facebook to encourage to the people to talk about the history that they know, people from San Miguel, about the history and all information that they have about the observatory. And another thing that is very interesting is that we receive a donation of, here is Santiago Mayesi and Rafael Girola. Here is it's a white color, but it's in this screen it was the Orion Nebula projected from the telescope. And this is the image of Orion Nebula in these skies that I made with no more than 27 shots of 20 seconds at 400 ISO 400.
Okay.
With the 11 inches Schmidt-Kasser and at 6.3. But it's a suburban area. But this is what's interesting because it's to show for the people, especially for the government, over the the capacity to make to recover the observatory, to put better equipment, new equipment to add to the old equipment, put bigger and better equipment. The idea of this is that today, with a field work, you can have image like this in a suburban skies. This shows the potential of course, that Orion is easy to make anywhere, but for people that need to understand, and people that work in a government, the major, and say, okay, you can make this. Yes, this is why it's important to make, again, a place where we can do it, something like this, not only to make a beautiful image, if not an image to start to make science, to investigate, to take measures of photometry, astrometry, and this is why we show to the authorities of San Miguel this image about the potentiality to have something for education, for science, or it's not only a beautiful image. If not, it's something that where you don't have the expect to have a place that is not in the middle of the mountains or rural areas. You have the capacity to recover a place, an observatory like this, to make why this.
Okay.
It's the idea.
Thank you, Cesar. That's great.
It's a pleasure. It's a pleasure.
So we look forward to the next your next talk on this facility and all that you're doing to restore these telescopes. So, but it's very encouraging that you got the first one up and running. And I had never in my life heard about a onyx stone solar filter before. So it's very interesting.
Me too. What's incredible.
Yeah, very interesting.
Yes.
Okay, well, we're going to stay down. Go ahead, Cesar. Go ahead.
Thank you. And I some Tuesday I'll be transmitting from the place. It's my idea. It's not easy every time, but my idea is transmitting for the Global Star Party next time, maybe in 2 weeks more. I don't know. Image from the moon, with the old telescope.
Yeah,
with the old.
Wonderful. It'd be great. Maybe we can do a connection for a live view from there. That would be awesome.
Absolutely.
Cesar, thank you so much. Thank you.
It's a pleasure.
Yep. We're going to stay down in South America. And our next astronomer is Rodrigo Zeleda. He's been on the Global Star Party many times, but he's got clear skies down there in La Serena. And he, last I checked on him, he had the Eta Carina Nebula in his telescope. So we're going to switch over to Rodrigo. Are you there, Rodrigo?
Hi, Scott. I'm here in La Serena.
Yes.
Today is a clear sky, very, very clear. And I take pictures for the Eta Carina Nebula in the south. I test the new mount in my store, the same 26 mount, and I take a local position. I check with you my screen.
Sure.
First, imagine for the QHD camera.
Okay.
Okay. Do you see my screen now?
Not quite, but I can tell. Yes, now I see it. Oh, wow, you got quite a bit of detail already.
Yes, this is the one light of the Eta Carinae Nebula with my telescope, Explore Scientific Apple. And
wonderful. That's the 102, the 102 telescope?
102 millimeters, yes.
Okay.
And 10 minutes of exposition. And wow. I process a little process in PMC-Eight, and I share with you my screen for PMC-Eight. Okay.
Wow.
This picture is at 10 minutes. It's one line. The color is maybe like a purple for the light pollution filter.
Mm-hmm.
And this another line is 5 minutes of exposition.
Wow.
It's better.
It's been amazing. I mean, it's just such a beautiful nebula, you know.
Yes,
and of course,
this sector, this star in my cursor is Eta Carinae star.
Wow.
This nebula is amazing.
Wow. It's beautiful.
It's a bubble of stars in the skies.
Yes. It's beautiful.
Yes, in a few minutes, and in my house, this backyard.
Yes.
The wall is very high. It
blocks out some city light. Does it?
Yes. This wall. My backyard is dark, but the skies is blocked for the wall.
Yes.
But in about 20 minutes, I put to the telescope to the another nebula in the south.
Okay.
Is the running chicken nebula.
Okay. The running chicken. All right.
Yeah.
Wonderful. Wonderful. Rodrigo, thank you very much. Thank you.
Sounds Scott.
Yeah. Yeah. And thanks for, I know that you were watching when I was broadcasting to the Astronomy Club in Chile last night. So thanks for watching.
Yes.
Yes.
This show is very, very great show.
Right. Very good. Okay. So up next will be Molly Wakeling as astrophotographer. And I'm glad to see Gary Palmer here tonight. Gary, it's been nice. It's nice to see you. It's wonderful. Molly, you mentioned that you were a little clouded out, but that you had some recent images that you might be able to share.
Yeah, I was hoping to share some telescope views tonight, especially because I just got a new filter for my color camera.
That's why it's cloudy. That's why.
Oh yeah, you're right. Well, it's that time of year in this part of California where it rains a lot, which is good for later in the year to prevent wildfires. But right now it means I don't get to do much astronomy. But I just got the Optolong L Extreme filter, which is a duo narrowband filter that I'm using with my color camera on my Takahashi. And I was hoping to show some views with that, but alas, maybe next time. But I do have some recent images that I've just processed in the last couple of weeks to show off to you from my backyard here in the Bay Area. So I will share my screen. Let's see, I'll just do that. All right, so first little introduction to my my backyard setup. If you've been on this stream a lot, you've probably seen this picture from me before, but this is my backyard menagerie. I have 3 imaging telescopes. The leftmost one is a Celestron 8-inch Cassegrain on a Paramount with a monochrome camera and a full set of filters. That's my primary imaging rig. The middle one is my secondary imaging rig, which is a Takahashi refractor with a a ZWO-294 color camera on the back, and light pollution, and now the LX stream filter, and it's on an Ioptron 740. Then the rightmost one is my science imaging rig. So I do imaging for the American Association of Variable Star Observers on this rig, and it's a Vixen Newtonian 800 millimeter f4 with a QSI CCD camera on there.
Wow.
The first picture to show actually is the result of the live stack that I did the last time I was on here of the Rosette Nebula in hydrogen alpha. And I did a little bit of processing on it. And this is a live stack of 16 5-minute images, so an hour 20 total in hydrogen alpha from my 8-inch Schmidt Cassegrain. So we're looking at the core of the Rosette Nebula here. There's a lot of really cool, fascinating detail in these dark fingers here, some globules here, some rings of gas here. And this hole punched in the middle of the Rosette Nebula is a result of the hot young stars that are recently born here in this nebula that are emitting lots of ultraviolet radiation that is not only that's what makes the Rosette Nebula glow, but the stellar winds are carving out that hole in the middle.
That's an amazing, and it looks so 3D, you know, to me. It's spectacular.
Thank you.
In color or black and white, it's just an amazing object to investigate, because, you know, this is a region of star birth, you know, this is a nursery of newborn stars are here. So.
Yeah, I like imaging in just single, like monochrome hydrogen alpha, because you really get incredible contrast, and you can kind of get that 3D effect. And it's fun just to, like, I'll usually also get color on it and produce another image, but sure. Producing just the hydrogen image is also a lot of fun.
Yes.
The next one is a wider view of the Rosette Nebula. This is from my my Takahashi. So this is not from the Takahashi. This is from I have a Rokinon 135 millimeter f2 lens that I mounted on top of the Takahashi. That was my present to my Christmas present to myself, and spending my second stimulus check.
You know, for a camera lens, and I've looked at images with a lot of different camera lenses, this does a remarkable job. I mean, those stars are pinpoint to the edges.
Yes. That's why I mean, this lens is incredible. I got to use it initially when I went down to Chile in 2019. I got to borrow one, and like of any lens I've ever shot with, which hasn't honestly been a whole lot, and most of them are cheap that I've shot with, but it really does there's no chromatic aberration. There's very little coma. It's an incredible lens, and it's only a $500 lens, which sounds like a lot. Unless you're an astrophotographer, then you're like, only $500.
Only $500. That's a deal.
Yeah,
that's right.
As far as camera lenses go, though, that's actually on the low end of how much camera lenses can cost.
Very true.
So yeah, I'm very, very pleased with this lens. And this is from, again, my backyard here in the Bay Area. This is not with the LX stream, because it finally just arrived in the mail last week. This is just with the light pollution filter. And I was very happy to pick up a lot of that background nebulosity that surrounds the Rosette Nebula in this region.
Yes. Yeah, and there's a lot of other nebulosity associated with that. I imagine if you just kept going deeper, it would just maybe fill up with nebulosity. So
yeah, I'm hoping to repeat this image in the future from a dark sky site.
Yeah,
and be able to go even deeper. This is 8.5 hours of data shot over 6 nights in mid-January, 169 3-minute subframes. Just poured a lot of time into this one, because this is my favorite target, one of my favorite targets. And this last one here is actually no, second to last one. This is, well, it was supposed to be Markarian's chain. I somehow must have put the coordinates in wrong or something like that, because I landed in another area of the Virgo cluster by accident.
Okay.
But even though there's not a whole lot to see here when you're zoomed out, if you zoom in, there are dozens or hundreds of galaxies in this area. All of the pink and blue labels that you probably can't read on the other end of YouTube are galaxies. And the constellation Virgo is in a part of the sky where we're looking above or below the plane of the Milky Way, depending on how you look at which way is up or down. We're looking outside the plane of the Milky Way, where we can see a lot of other galaxies in the universe that's not blocked by the gas and dust that, if we look toward the Milky Way, blocks a lot of galaxies in that direction. So if you look up toward Canis Venatici or Virgo, there's so many galaxies in that area.
Yeah.
You know, if I zoom in, there's some larger ones that earned Messier numbers. There's some medium-sized ones that have NGC numbers, and there's some itty-bitty guys that have IC numbers.
Oh my goodness! Look, they're everywhere.
Yeah, and I did some searching on some databases online, and the galaxy distances in this image range from some of the Messier objects that are at 50 or 60 million light years away to some of those itty bitty IC objects that are as far away as 600 million light years.
Oh my goodness. Wow.
And this was again with that Rokinon 135 millimeter f2 lens on a tracking mount in my backyard in the Bay Area. And you know, one of these galaxies here is some hundreds of millions of light years away, and I can still see it from
and
here.
You get it. And that's amazing.
Yeah, it's so cool to be able to realize that and see what all is out there, even on amateur equipment. And this is 9.5 hours of data, 114 5-minute images taken over 6 nights in mid-January. Yeah. Finally, the last one here is this one I just processed the other day. This is the Seagull Nebula. I've been getting through all the data I took on that Rokinon lens over the 6 days that I was testing it out here in my light polluted skies. And this is a nice wide shot of the Seagull Nebula. And it was actually, the nebula itself was quite dim. And I used a technique in PixInsight where I used StarNet++, the tool that removes the stars. And then I was able to play with just the background and not oversaturate the stars while I brought up that nebulosity. And then I mixed the stars back in to the image so that I could still have a nice star field that was well exposed and be able to have the background, like that much dimmer nebulosity of the Seagull itself, be able to show up and not be too dim. This little guy here is GUM1, it's got its own name, and I'm actually imaging this currently on my 8-inch Schmidt Cassegrain, and I've almost got enough data to start processing it. Need a couple more nights. And this guy over here might be familiar, if I can get over there. This is Thor's Helmet, or the Duck Nebula. And it's also been very high on my list and to image, and I'm imaging it right now on my, well, not right now because it's cloudy, but
right.
on my Takahashi, which has a much smaller field of view than this camera lens. And it's actually, no, I'm doing it not on the Takahashi, I'm doing it on the C8 as well. That's right, because I'm getting narrowband on it, oxygen and hydrogen. As you can see, there's a lot of oxygen here, and the oxygen frames I've gotten back so far look so cool, and that's just like single frames. So I'm really excited to process.
Oh yeah, it's very intense.
But yeah, it's right there in the same kind of area as the Seagull Nebula, if you never realized that those two were close to each other. And there's some other.
It looks like there's some nebula almost like right in the center of that. And really faint. Maybe that's just maybe it's just an artifact of my screen.
Well, so we have the Seagull here. And
Okay.
then there's kind of a little, another like hot spot up here lit by this bright star here. And then there's a little bit of nebulosity over here as well that I was able to pull out. And there's a couple of open clusters, whose names I can't remember offhand. One's Messier, I think it's Messier 50 or something like that. And then another is NGC numbered open cluster. And then there's this little guy here. It's like it's a sharpless object. I can't remember its catalog number, but a little sharpless nebula here.
Very cool.
and
Very
a little
cool.
bit of reflection nebula up here, actually. Yeah,
It's
so
always exciting to catch up with you, Molly, and to see what you're working on. And all of your imaging, I don't know if you keep a catalog of all your images,
I
but
do, yeah.
how many objects do you think you've imaged so far in your?
So I actually have a spreadsheet.
Why did I know that you had a spreadsheet?
Yeah, it's currently open because I was adding my latest targets to it, and I keep one of the pages of the spreadsheet is a statistics page. So let me go see. I have imaged 95 unique deep sky objects for a total of 312 data sets.
Wow.
And a total of 690 hours of data.
Wow.
And that's just the deep sky objects. That's not solar system. So like planets and asteroids and stuff like that. And that's not variable star data. That's just my deep sky objects.
Wow. Impressive.
And that's over the last 5.5 years.
Wow. So you just started 5.5 years ago, and you're really doing some amazing stuff, you know, and I love the way that I mean, you're not only on our program, but on many programs, sharing your expertise, your beautiful images, and your inspiration. So thank you very much, Molly. Thanks for coming on.
Thank you. I love sharing.
Yeah, thank you. We love it too. Okay. I noticed that we have Gary Palmer here. Gary, I know it's late. And we have Pekka is also on with us. And so, Gary, why don't we have you on first?
Hi, Scott. Hi, everyone.
Yeah, it's
Hope
good
you're
to
all
see
well.
you. It's been a while since you've been busy.
Yeah, just been busy, or there's been other things going on at the moment. So, yeah, weather's no better. It's just the same as usual. If it's not snowing, it's raining.
Right.
So yeah, but still been managing to get a few bits here and there. Nothing tremendous. It's just working odd hours and grabbing an hour here and an hour there, wherever it clears, and sort of working from there. So
I saw a was it the jellyfish nebula that you posted on
yeah.
Facebook?
Yeah, we've got that.
That was somebody commented. They said, "Is that real?" You know?
Yeah,
it's just beautiful.
There we go. That.
Yes, look at that.
Hopefully, that should be on the screen.
Yes, it's on the screen. It's spectacular.
So it's only 3 hours worth of data. So yeah, it's a little bit colourful. Probably could do with a little bit less colour in it than that, but. When you're running with 3 hours of data in narrowband, you have to push some things sometimes just to bring the detail out. And at the moment, I don't know when I will get back onto the target.
Sure.
So we've got quite a backlog of equipment here at the moment for testing with the weather. And there's boxes turning up all the time and no clear skies to test. So it might well be that we don't get back onto this till next year. Or later this year at some point. Other things that we've done over the last couple of weeks, that was tonight in actual fact. I had a hour's clear spell tonight, so it was just a quick moon shot. These are all through that FCD 102 that you sent over.
Okay.
So that's still on the mount at the moment.
Great. Gary, do you have like an alarm or something that goes off and says, "Hey, it's getting clear, run outside and take pictures"?
I'm generally working in the office and the observatory is right next to me. So I do have a camera that looks up the night sky and gives me quite a wide field view, but I'm quite remote here. So getting a good weather forecast is quite hard. And rain showers can just appear even though they're not on the radar. So last week, some of the equipment got a soaking for about 5 minutes while the roof was closing up. Tonight was close. Yeah, just managed to close up before it come in. So that, unfortunately, is one of the things. Other stuff that we've done this week, Thor's helmet. It didn't come out that good. It's really low from here. So I'm going to try another camera on that. The data's there, but it could just be clearer. And I think
Gary,
again,
if I took an image that good, I would be, you know.
Yeah,
I would just be amazed. You know, so. It's a beautiful image. It is.
From my point of view, the object's there.
Okay.
It's the old schoolboy thing. Could always do better.
Yeah.
But again, it's a target that's quite low here, and I only get 2 hours on it before it clips the main building on the house. So
I see.
It's another one. I've tried it a couple of times. It's never my favorite image when it's there together, although it really annoys me. But one year when we're not in lockdown, I might move a rig up into the mountains and image it properly.
Sure.
So Sombrero Galaxy M104, that was up early hours of the morning. That was about 4 a.m., 5 a.m. here. So yeah. I thought I'll get it now, because when it's actually in season, it won't be clear. That's my philosophy. Is
that's the way it works.
Target, just grab it. And same night, Leo triplet.
Yes, I love.
These are all an hour's worth of data, so they're nothing. They're no hours and hours worth of imaging. And that horse head, I think we had up the other week. Yeah, so that's again hours worth of HA data on the horse head. So apart from that, not a lot's gone on.
Well, it's quite a bit.
Let me just go back to wherever that is and share the other screen for a second. There are some things to keep an eye on. Now, this is a real schoolboy error that I made tonight. I have reworked this, but if we actually look at this, the colors are all wrong in the image.
Okay.
So about 2 years ago, I reviewed the ASI 294 camera.
Yes.
And I think the last thing that I probably will have done on it is taken a moon image. So I had a new one come in this week, put it on tonight, thought we got an hour or two there. We'll just run around the sky and grab what we can. And what I didn't pay any interest to, which if I just grab the data file up for it, if you give me 2 seconds. Where are we? Just got to go into here and I'll grab one of the single images over. Anyone to do? What I didn't pay any interest to at all on the camera settings, apart from exposure and everything else, was that the image is actually flipped. So quite often when I do the moon, I will flip the camera. So if we actually look at this, yeah, and we run this under its standard RGB debayer, then it comes out blue, and that's because the image is flipped. So it's something worth bearing in mind, that sometimes the software holds everything in there for a long time. So I thought, well, there's definitely something wrong on this. And when I went into the header files and the text files with everything, probably better off with the text file on this one. Then as we start coming down here, you can see flip in both directions, and that puts your debayer system right out. So you have to sit there for half an hour going through all of the different debayer patterns until you find one that works, which is now corrected. I've actually run that through while you've been online, but it does show you that you need to keep an eye on some of these settings.
If you unflip the image in PixInsight before you debayer it, you can use your original bayer pattern.
You can do, but there's so many in the sets here that it's actually easier just to pick another debayer pattern.
All right.
Yeah, it's easier just to run down here and debayer under the correct pattern for it. So you can use other programs. So I used AstroArt because AstroArt will read the debayer out straight away for me, and then I can just run into the debayer system in here.
I've had to do that with my flats a number of times when I've taken flats and left the flip on.
Yeah. And there's also a new weighted batch processor in PixInsight today, and that's also already had an update this evening on that. So I expect a few more updates, but that's looking quite a bit different to our normal. In actual fact, I could open up the one that's here. Just give that a couple of seconds to open up. So we've got a totally different layout now on how this is working. And that brings everything into another tab on the top here, the control panel, where we can go in here. By selecting on here, we can go in and do all of our different settings through there. So it's just taking a little bit of getting used to everything being in a different place from what it normally is. But it seems to work okay. That's the main thing at the moment. But yeah, apart from that, all's pretty much the same.
Excellent. Okay. Well, our next speakers will be Pekka, who joins us on a lot of our programs, our daily shows. He's been in the audience. He's always has interesting comments, and it's great to have him on the program. We're going to, as we transition, we're going to take a peek at Richard Grace, the Astro Beard. He's got a stacked image that he just did of the Orion Nebula. So he was lucky enough to get some clear skies. You want to share your shots there?
Yeah, absolutely.
Okay.
Let's see here. So this, where is it? 100 stacked images of 40 seconds.
Okay.
I might add trash cans are blowing around everywhere outside right now.
Oh, really? Okay.
So I mean, it's still popping them in there. So if it's not, 100% perfect in here, but let's see how we're doing with 15-20 mile an hour winds.
Not bad.
It's a little oblong. I wasn't expecting awesomeness, but it's working real good. My main thing is tonight's a first test with a new mirror system here, and I want to show this again. Earlier, this was the old mirror, and you can see how the center of it's real, flat, and then the outside of it wasn't. And then you transition over to this, and you can see, just a little bit of corner, you know what I mean? And I
definitely, but a lot more illumination.
Definitely live with that. It's all flat illumination, and because we're showing live images here, I don't like that real hot spot in the center look and all that type of stuff. So I want a nice flat image, and it's looking great.
Yeah, and this is totally unprocessed. This is right out of the camera, right?
Yes and no. I do have in the live stack here, like if I hover over this, I have manipulated the histogram, but there's no darks, no flats, nothing like that. This is just straight out of the camera into a live stack, and just the couple adjustments that SharpCap lets us do.
Sure.
And I just wanted to toss that in there real fast.
All right.
And I also wanted to say one more time, if I didn't, thanks to Ostahowski Optics for sending me that mirror. It's awesome. Thank you very much.
Yeah. Terry Ostahowski and I worked together at Mead Instruments, and he's a great optician. And that's just testimony for it. Okay.
Thanks for giving me that heads up, by the way, too.
Yes. Pekka, let's have you take the stage here for a little while.
Thank you, Scott. First of all, it's an honor to be here.
Yes, we're honored to have you. So thank you. Thank you.
Yes.
Pekka, I have forgotten where you live. Where?
Stockholm, Sweden.
Okay.
A suburban called Kista. It has been called Swedish Silicon Valley because we have all electronics companies here. IBM, Ericsson, Oracle, Microsoft, all the big companies, and very much research in high tech.
Silicon Valley of Sweden.
Yes.
Yes. Very good.
Okay. I don't know where to start. I have.
Let's start by have you give us a little bit of an introduction to yourself and.
Yes.
And
okay. I began to be interested of astronomy, especially moon, when I was 9 years old, 8, and both my first telescope when I was 9 with self-earned money. Can show you. It's over here.
Oh, you still have it. That's good.
It's I found a similar.
Okay.
It's 30 millimeters.
Yes.
And this is authentic. I had white, and this is like pirate.
It's
But this is exactly right. I had, and it has been, the interesting has been there all the time, in the bones, in the cells.
Yes.
And then I became a teenager. Girls came in the picture, cars, you know, and so on. And then I get a family, and that's it. But something happened for right 1 year ago. I have been sick, very ill for 7 years, and I got my transplantation for 1 year ago. And week after, I decided that I will dedicate my rest of my life to this hobby, because I have lost so many years between. So right now it's double turbo, it's all trust open, and we are
light speed ahead.
Light speed ahead.
Yes.
And I never done astrophotography before. I took my first photography ever last April.
Okay.
And that was freehand moon, and then I took my 8-inch telestron and with my DSLR and catch Venus.
Oh wow! Good.
I didn't know anything about processing, anything. So I began to read, and I can show you some pictures of those. And then after that, I have had maybe 6 totally clear skies since November.
Oh,
so every possible night.
Anytime it's clear, you're out there.
Yes, because this is a terrible year.
Yes.
This year, when I wanted to learn, I have reading, but I need practice. But that was not possible. So I have inside, because I am I don't have any immunity after transplantation. You need to take lots of drugs. And
there's something I want to do for you. I will buy you a session, a learning session on our ED 165 telescope at the MSRO. And you can work directly with Jerry Hubbell, and he will teach you how to make amazing science images. He will.
Wow.
Okay, so we will set that up.
Okay.
Yes.
And I have been looking for an Explore Scientific scope here in Sweden, but there is no resellers here in Sweden. The nearest one in UK, but there is no scopes anymore in Europe.
Or in the United States, for that matter. Everybody bought all the telescopes.
Yeah, but I want the 157 carbon fiber, triplet.
You want the triplet.
Yeah.
We might be able to make that happen. We do have some telescopes that are certified pre-owned. Okay.
Okay.
Maybe we can do something. So get in touch with me later.
I take the high level right away, because I spent a lot of my spare money on this 1 year, but I thought, which one makes me more happy? The money on the bank account or the money on my stuff here? So that's my way.
I get it.
I can show you if you want some. There is a few. We can start with. Let's see how I do this. Share screen, and then I have to pick up here, I think. Then take there. Can begin with this one.
Right.
This is my observatory.
Can you bring that up
there?
Full screen for us?
It's that not full screen?
No, you might change your share screen to focus on the app. You'll see that if you stop sharing and then you go and share again, you'll see that there is different things that
share
you
screen.
can share. And go back again, click share screen, and then pick the full screen view.
Okay, I have to go back here.
Yeah.
And then share screen. And then I got the option for this screen, and then my Explorer and Advanced.
Jeff Wise is saying it could be in the background. So
it's sometimes easier to select your whole screen to share. That way, when you switch windows,
yeah,
because if you choose like Explorer, it will grab on to the Explorer window, and we won't be able to see anything else.
Okay, then I first share screen. Okay.
Okay.
And then
you can select. I don't know if it might call it desktop or screen one or something like that.
Yeah.
Okay.
So
you see it now?
So I think you still grabbed just the Explorer window and not.
Okay, if I maximize it.
Let's try.
It's better now?
Because we're only seeing your folder. We're seeing your Star
We're
Party
seeing the folder. That's right.
Okay. Shit. This I tried it today.
It's okay.
Share
we
screen.
all had to learn how to use it.
The green one. Share screen.
Yeah.
Yes.
Okay.
And then instead of choosing Explorer, choose whole screen or desktop, or I don't know exactly.
Yeah, where we see everything on your computer.
Yeah. I only have these options. Screen, that's the screen. This screen.
Yeah,
there you go.
Screen.
There you go. That'll work.
Okay, that is my balcony where I do my astronomy.
Nice.
Okay.
The mouse is there 24/7 on the blankets. First is the heating blanket, and then ordinary blanket, and then tarpaulin.
I see. That's how you protect it. I understand.
Yeah, and I have moisture meters and temperature meters below everything, so I can adjust the temperature and so on, depending on how cold it's outside. And for summertime, I have a small fan that circulates the air. Okay, and let's see, we have to can show my
now we're
room.
seeing your whole desktop. Okay.
This is my working room.
Yeah, there's mission control right there.
Yeah.
That's great.
And my stuff. There's my two CSTs.
Oh, you have a mirror right there. It looks like you have just an incredible collection of telescopes.
Yeah, that's a mirror.
Let me ask you a question, Pekka. You were mentioning how astronomy makes you happy.
Yes.
I gave my lecture yesterday to an astronomy club in Chile. Was all about that. It was how by stargazing and doing astronomy that you can connect. You can kind of connect with the whole universe.
Yes,
you know?
because when I do visual and all over astronomy, only then I can feel myself like me.
Yes.
Deep inside.
Yes.
Because that was like a born again 1 year ago, and I realized what is the most important for me in this life, and that is the life.
Yes.
Nothing around it. Not that's around that. That's the core of everything. Then you can build something like that around. But there's my refractors.
Yeah, your refractors. You have a nice collection.
Yeah, I tried. That's my old mount. It's a GM, but it didn't deliver because it cannot hold my 11-inch with everything. So
yeah, that's a big telescope. Yes.
Yeah. So now I have a CGX instead.
I see.
That's my first ever first light. That's a Venus with 8-inch.
Oh wow!
Canon 6D. Yes, I say that to myself. Oh wow!
Well, you can see the crescent phase. It's great, you know. So.
Yeah, and that was the first moon with an Orion 80 short tub.
Okay.
Without mounts, it was just laying on the balcony rack. You know what?
Sure.
So freehand almost.
Yes.
That's a Venus also.
Yeah.
Processed Venus. You can see those artifacts after. Yes. So, but okay, that's an Uranus.
Oh,
my first. Yeah. He's got.
Definitely see the color.
Yeah, it's blurry, but anyway, that's Mars. Now in September.
Very nice. Very nice Mars.
And Pleiades M45.
Yes.
Very noisy because I can't process yet.
Oh.
That's the problem. That's the processing skills.
That's a matter of time.
Yes. And I need data, and I can't get data because it's so cloudy.
Yes.
Messier, Andromeda from Portal 2 skies with the Star Adventure and 50 millimeters lens.
Oh, okay.
And that's processing also. This is the with ED 120 and Canon 600 modified. I think it's 60 seconds lights. And this is the moon with ED 120 and ASI 120 MC.
Oh, now that's nice. Look at that detail. Incredible. This is very good.
And this is yesterday with one ED 72 and an azimuthal small mount.
Your focus is dead on, Pekka. That's good.
Thank you. It's very difficult to focus on moon when it's daylight. This is 1 hour after sunset.
Yes.
And it's only, I think it's 17 degrees. And there is not much to focus on.
Right.
So that was just.
You've got a sharp eye. You nailed it.
This is the view I have from my balcony.
Okay.
And do you see those red arrows? Those trees was on the way. They took almost 30% of my view. And I told the landlord that I have an allergy, that they are too close. So they sent a what is called this who take down trees. So this is for,
they took them down.
They took them down. Yes.
That is so
Now I have.
clever.
It was too close.
I'm allergic to trees.
I'm gonna have to remember that one.
So they took them down
Yes.
because I was complaining about they are too close. So I can never have my balcony door open at spring and summer.
Yeah.
So they took them down. So now I have a little bit more.
Yeah. That's
and this is the last message for everybody.
Yes. That's very important.
Yeah.
That's very, very important.
And that's my balcony from outside.
Ah, okay.
Those trapezes are just for light pollution and for snow. I don't want snow on under my feet.
Sure.
So I live in bottle 8 scale area.
Wow. Well, you're doing very well. You're doing.
Thank you. Thank you.
Yes. Okay. Well, Pekka, I definitely want to get you on the MSRO remote observatory.
Okay.
So I
It
will
would be more than we'd be more than happy.
I'll give you some more skies. Yes.
Yeah. It has been terrible. Yesterday I saw the moon, because first on the day you have to look it with binoculars because it's so narrow, and when you find it, okay, you got grab your telescope and begin to look it with your telescope. No chance.
Oh.
And then I took my smallest one and an azimuthal mount and pointed and got it, and okay, I had 2-3 minutes on me because the cloud began to roll over from west.
Oh, geez. Yes.
So I must have something. Anything.
Okay. All right.
Thank
I will
you,
be
Scott.
happy to make this happen. So.
And to Molly and Gary and everybody, you are my inspirations sources. Really. So Molly, you are taking on that observatory you have on your background. It's something you don't do.
Yeah, it's a lot, but I love it.
Yeah, and I admire you.
Thank you.
Pekka, thank you for sharing.
Thank you, Scott. It was an honor to be here.
Yeah, it's an honor for us too. Thank you.
Thank you. Thank you, Scott.
Okay. All right. So we are, I guess we're coming towards the end of our show, but no need to end it here. We've got time to share with anyone. Rodrigo, you mentioned that you might be on another object by now.
Hi, Scott. Now the nebula running chicken is on my telescope, and I take one picture.
Okay.
Share with you from the software of QHE. Hi, Scott. Do you see my picture?
It's coming. The bits and bytes of the internet are coming. There it is.
This is my.
Wow. Now this is the QHY imaging platform, or which software are you using?
Yes, I capture with the software for QHE, SZCAP, and I process images in PixInsight.
I see.
It's a old method.
Yes.
This nebula is the running chicken nebula, and the constellation of Centaurus.
Centaurus.
Centaurus. This star is Lambda Centauri. And
Never seen a chicken or anything running in that nebula.
You never
named that thing.
with mud field.
Well, it takes a lot of that imagination
This
that
sector
Liz
is
talking about. So
the chicken. And the
If I turn my
three little
head.
nebula, like, but it's very difficult to see the chicken.
yes.
This is my. Okay.
Was I guess it was discovered only in 1950, so relatively recent discovery by David Thackeray. And then the globules are now known as Thackeray's globules.
Yes, in this sector is John cluster and blocks here. Do you see my picture now in PixInsight?
Yes.
Yes. This is a Lambda Centauri star. This is a block and John cluster.
That looks great. I still don't see a chicken. But that looks awesome.
Wait a minute. I think maybe if I'm looking kind of. Oh, I see it. I see it now. Okay. All right. So the upper left-hand side. Okay. Upper left-hand side. You can see the chicken's head. Okay. So that going up towards the top, his beak is aiming. Let me see if it was a clock. It would be at about the 10 o'clock position. Okay.
Yes.
At the upper left-hand side is his head. Okay. His foot is all the way at the bottom. Okay. His foot is a very faint outline of his foot. All right. And he's pushing off and he's got his wing out like he's running like a man. Okay. Like this. So he's got like a profile. He's going down like that. Okay. Running across the sky. And that is the running chicken.
I guess my imagination is just not as good as yours, Scott.
Well, this object is 6,523 light years away, and it's about 71 light years across. It's a big object. So beautiful, though. It's nice to see that kind of object there. And good job, Rodrigo.
Sounds good.
Thank you. Thank you. Anyone else have anything to share? How about you, Chuck?
Nothing along the line of imaging. We haven't had a clear night here since January 12th, as I told you. It's been unbelievable.
Yeah.
I mean, not even the sun during the day, a little bit. I do have one little thing I can share, if you have a few moments.
Sure.
Let me go to it. It's not the right one. Hang on.
Chuck, you always have the most interesting, amazing things. Your presentations are awesome.
Well, thanks. I've got to find this. What did I do with it? Okay, that should be it. Okay, let's try this. This doesn't look very astronomical. I think most people out there who, if I ask them how far it is between their home and their high school, if they're in high school, or if I ask anyone of any age how far they thought it was from their home to their high school, they would have a distance. They'd say, well, it was a half-mile walk. And if it was a half-mile walk, that has meaning. It has meaning in the sense that you would say, well, I know I can walk that in 25 minutes. And if it was true when you went to high school, it's still true today. But when we start talking about cosmological distances, things get a little more complicated. Now, I'm showing you this object here because it happens to be the furthest galaxy that has ever been imaged. GNZ11, it's called in Ursa Major. And the descriptions that we read about it in many articles, Scientific American, Time Magazine, and so forth, are that GNZ11 seems to be the farthest detectable galaxy from us at 13.4 billion light years. Now, the question is, what does that mean? And is it really 13.4 billion light years away? And the first thing we need to understand when we start talking about distances is there are a couple of complicating factors, and I'm going to try to simplify them. And one of those, of course, as Dave Eicher pointed out earlier, the universe is expanding at some rate that is approximately equivalent to 48,000 miles per hour for every 1 million light years of separation. And that means essentially that if you had 1 billion light years separating 2 points, you would have a separation rate of 48 million miles per hour due to the expansion of the universe. Now, as David pointed out, that doesn't apply to gravitationally bound systems. So the distance between your home and your high school is not changing. The size of the Earth is not changing. The Milky Way is not expanding, and indeed, even the local group of galaxies. Our relationship with Andromeda and M33 is not changing. In fact, Andromeda, as David pointed out, is getting closer to us because of that gravitational attraction. But on larger scales, between the local galaxy groups across the voids of space, the universe is expanding at this rate. That's called the Hubble constant, which is kind of a misnomer because the rate has been changing throughout the history of the universe. But it is constant in the sense that it's the same, we believe, everywhere in space at any given time. Another complicating factor is that there is a distance from us that, because of the expansion of the universe, is moving away from us at the speed of light. Now, take this slide, for example. I said at 1 billion light years, you'd have a separation rate of 48 million miles per hour. That's 1/14 the speed of light. So it stands to reason that a little past 14 billion light years from us, because of the expansion of space, it will carry objects like this galaxy here and us apart at greater than the speed of light. This doesn't violate special relativity at all. We're not observing anything moving faster than the speed of light. Nothing is moving through space faster than the speed of light. It's just the separation rate, perfectly allowed. Another complicating factor, as I alluded to, is that this expansion of space has changed over time. It started very fast, and then matter, the gravity from all the matter in the universe, started decelerating the expansion rate. And then about 8 billion years after the Big Bang, dark energy took over. The matter became more attenuated, dark energy took over, and now it's accelerating in its expansion. And the final point is that the expansion and the speed of light make distances harder to understand. And this is where we come back to GNZ11 here. There are several possible distances you could assign to GNZ11. The first would be, well, how far away were we from it when the light left there that made this image? And the answer is somewhere around 1 billion light years, because the universe was much smaller when that light left GNZ11 and started winging its way toward us. And it was bright white blue light because these are brand new stars. It's a little tiny protogalaxy. It's only about 600 light years across and has only about 1 billion stars. They're just forming. It's the first generation of stars to form after the Big Bang. That's how far back in time we're looking. But as those photons started winging their way toward us, we began receding from it because of the expansion of the universe. And so those photons ended up having to travel 13.4 billion light years before they reached us. And by the time they did, this galaxy had receded to a distance of 32 billion light years. You'll notice that none of these distances are really very satisfactory. We can't say it's 1 billion light years away because we know the light took 13.4 billion years to get to us. We can't say it's 13.4 billion light years away because that's not where it is today. If we could instantaneously fly up that light path, 13.4 billion years in an instant, we'd find nothing there. And it's very difficult to say it's 32 billion light years away, since how in the world would light get to us from 32 billion light years in the 13.8 billion years that the universe has been around. So this makes talking about distance very confusing. So let's simplify it a little bit.
Okay.
Here we have Dad and his daughter. And his daughter is hanging onto the wall. She's been taught how to do the crawl. And Dad wants her to swim to him. Now, he's not going to do what my dad did to me and start backing up in the pool as I swim to him.
Right.
But this dad's just going to stand still and beckons to his daughter to let go of the wall and swim to him, just 10 feet away. But this is a magic swimming pool. It expands like the universe. And so as the daughter starts to swim, the pool expands, including the water between her and her father. And so by the time the daughter gets to Dad, she's ended up swimming 100 feet, not the 10 feet originally. And then when she turns and looks back, the wall's 300 feet behind her. So that's GNZ11. We were 1 billion light years away when the light left the wall. The light ended up having to travel 13.4 billion light years to get to us. And when it did, the galaxy was 32 billion light years away. That's called the co-moving distance. So that is a little tricky business on distance. If you were going to draw it in circles like this gray area represents the area from which light's had 13.8 billion years to get to us.
Okay.
Okay. So the light has traveled 13.4 billion years, but the galaxy isn't really there. It's way out here at 32. Okay. The furthest thing that could possibly have gotten to us in that time, and there are lots of galaxies, of course, that are closer, several trillion, probably close to 2 trillion galaxies, all of which are closer than GNZ11. And their light has taken less than 13.4 billion years to get to us, and they're today out here somewhere. The furthest that light could possibly have gotten to us in the age of the universe is from 13.8 billion years. And if there had been a galaxy shining 13.8 billion years ago, that galaxy would be out here at 46. And that's what we call the cosmic particle horizon, or astronomers like to refer to this as the edge of the observable universe, because that's where the furthest things that we can see actually are right now. However, there's another question. What about this little dude here at 15 billion light years? Notice that it lies beyond that distance that's moving away from us at the speed of light, that 14.4 billion light year distance. Okay. So if a supernova went off there today, we're not talking about old light like GNZ11. We're talking about light that leaves there right now, today. Could it ever reach us from beyond that point that's moving away from us at the speed of light? It would seem like the answer is no, but actually it can, because while the space between it and us is separating it greater than the speed of light, if those photons can find a way to get inside that 14.4 billion light year distance, they'll make it the rest of the way eventually. And in fact, the distance between 16 billion light years, or 15 billion light years rather, and this 14.4 is not expanding faster than the speed of light. So the photons can make it inside. They can make it the rest of the way. And that's true right out to 16. At 16, a supernova goes off. That light can barely make it to us. But beyond 16, no.
Wow.
There's simply too much space beyond 16 billion light years between that Hubble distance and this galaxy for the light
of the universe. Then.
Pardon?
To us, I guess this is the edge of the universe.
Essentially, it's this. It's unreachable.
Yeah.
Any object that today lies at 16 or more, beyond 16 billion light years is unreachable. It can't get a signal to us. We can't get a signal to it, even using light. Notice, though, the GNZ11 is way out here at 32. So it's unreachable, as is this galaxy up here and this galaxy here. And in point of fact, 96.7% of all galaxies we can see now and 98.6% of all galaxies we will ever see are already unreachable They've already long ago sent the last photons to us that we will ever receive. And the reason for this can be seen in the pool analogy again, because if the daughter decides to swim back to the wall, she now finds that there's so much water expanding so fast that she can never reach the wall again, nor can anyone else leaving the wall ever reach that again. Horizons have been created by this expansion. So that's just a little taste of how difficult it is to talk about distances. Astronomers basically give up and just use the degree to which the light from the galaxies has been stretched. In other words, in the case of GNZ11, if they detect some light that would ordinarily have 3,000 angstrom wavelength, in the case of GNZ11, that would be now 33,000 angstroms in length, stretched 11 times. And so they call it Z11. That's the distance factor they use, and hence part of the name for the galaxy.
Okay. That's awesome. That is awesome. I've got a little movie that I can show. Let me go ahead and share my screen here. Let's see. There we go. And we have this movie right here.
Yes. It zooms and zooms and zooms.
This is from the Hubble Space Telescope.
It's not many pixels.
No, it's not. It looks a little raggedy. It's amazing.
This is the kind of stuff that kept me going in undergrad when I was not really wanting to do my physics homework.
It's so hard to wrap your mind around these things. It really is. This is, it's been a while since I've really kind of had my head hurt thinking about distances like this, you know, because when you're out with your telescope and you show people the Virgo cluster and you tell them, the distances or estimated distances to some of these galaxies, and you try to explain what even a light year is and these kinds of things, it really does. It makes people stop and trying to understand what it is that they're seeing and how far away this is and what do these light years mean and all of this stuff. So,
once Andre Linde, who was one of the great inflationary cosmologists, estimated that the size of the entire universe beyond the horizons that I described might be as large as 10, brace yourself, 10 to the 40,000th power times larger.
Wow.
That would be typed in 12-point times New Roman type, a 1 followed by 2 miles of zeros.
Yeah, that's a lot of zeros.
Yeah.
That is a lot of zeros. That's amazing. Jeff Wise says, Chuck is so casual and relaxed as he blows our collective mind.
I'm sorry. It was a gamble, but
that's right. A lot of people are dialing 911 right now. So
I think one of the things when you start reading cosmology, and I'm sure anyone who reads a lot about it goes through this, you'll hear constant things you just don't understand until you keep reading, and then these little light bulbs start going on, and then you get more confused about some other point and another light bulb goes on, and eventually it starts to make some sense. And there are a lot of great books out there to help you.
Yeah.
And eventually you get to graduate school and you're like, nope, I'm lost again.
Exactly.
Okay. So we have another gentleman, Cameron Gillis, who'd like to join us on the show. So I'm going to, let's see. I'm gonna try to get someone else on here. So, Pekka, one of the things I've been thinking about a lot is, you know, how I started down a path of wanting to write a book about how stargazing and astronomy is good for you, you know, similar to how if you go into people who connect with nature, they go through forests, they go, you know, they're out beyond the city, and they're, you know, they finally feel this this euphoria, this rush that comes about, and their blood pressure goes down and their anxiety goes away, and all these other things.
Yes.
These things happen to me when I am out under the Milky Way, you know, or I'm looking through my telescope, and you know, the knowledge of how small we are in the universe. You know, I often think of the Carl Sagan's pale blue dot, and
Exactly.
yeah, and so all the things that we think are so crazy and terrible for us or whatever, all of a sudden they're gone. They're gone.
I'm trying to explain everything to my family.
Yeah.
But it's too much for them. I begin to explain that everything you see is history. They don't get it.
Yeah.
So that we see has happened for millions and millions and millions of years ago. It's not because everything we look with our eyes is history.
Is history.
It's only 1 meter from our eyes. That's already history.
That's true. That's true.
And that's the fascination, because we are studying astronomy and physics, but we also are studying history.
Yes.
I went to library and asked some books to read, and he told me where his astronomy books was. And I told him that they are in the history department. No. What do you mean? Yeah, but that belongs to history because it is history. He didn't understand me. So I have to explain to him. Okay, then he got it.
Yes.
But every time I took my binoculars and pointed somewhere, it don't have to be any bright, because this 3D image I get, it's after that I forget everything.
Yes.
That's a whole own world. It's a small capsule you will drop in. You can hear, you can't feel anything. After 1 hour, when your feet are burning from frozen,
right,
then you can feel something.
I'm going to give Cameron the ID number. Let's see. Here we go.
But this has been wonderful year, and have to. When I found your channel, it has been very late nights.
Oh, I'm sorry. What time is it there right now?
Right now it's 05:17 a.m.
Oh my goodness.
So almost 5:30.
Yes.
My wife will soon wake up to work. She's working home because COVID.
Yes. Okay. So I'm giving bear with me here. Here we go. So Cameron, you have the Zoom ID and password right now. You can come straight into this program. Chuck, what do you think? How do you think that, I mean, you must have heard many stories and maybe even have a story yourself, but why do you think astronomy and stargazing is good for you?
Well, for one thing, there's no limit to how much of your lifetime it can fill. I started this when I was 7 years old, and I'm still doing it full time, basically.
Mm-hmm.
The sum total of it, observing, astrophotography, public outreach and teaching, just the social aspect of being with other people who share an interest with you. I mean, it's just an endless hobby, and it's one that professional astronomers rely on to help them with the public education function that there are simply too few professionals to execute. So they rely heavily on amateurs to be that arm, if you will, of the profession of astronomy, that is transmitting information to the public, to scout troops, to museums and libraries and schools around the country. It's very important. When I'm observing, and during COVID, I've been observing alone, and I drive 72 miles to a remote site to observe, and I don't feel alone at all. I'm mission oriented, as I'm sure Molly and others can tell you. When you're busy with this, you're focused on the work you're doing, and it's exciting. It's fun. There's a feeling of satisfaction when you've accomplished whatever task it is you're seeking to accomplish.
Yes.
It's fun. There's a feeling of satisfaction when you've accomplished whatever task it is you're seeking to accomplish. Yeah. It's fun.
Cameron, I think that you've got your monitor turned on. We can hear ourselves echoing back and forth. So you'll have to turn off the monitor turned on. We can hear ourselves.
Oh, okay, just a minute.
Now batting.
Yeah.
There we go. Can you hear me now?
That's right.
Okay, good. Is it echoing?
Not anymore. Not anymore. It's dark there.
Okay, great. Okay, so let me let's see here. What can you see here?
You can see like the moon, I think. Is that right? Or a light?
Yeah, that's right. That's what I want. Yeah, perfect. Okay, here we go. Okay, so it's a little bit delayed.
Yeah.
Well, we actually have clear skies here in Seattle. It just cleared up, so
very unusual.
I was motivated after seeing Pekka there and joining your webcasts here since the beginning of the year. I really want to jump on board here, and I wanted to share a little bit of viewing experience. I see Orion, and I see the moon. Sure. And let me just I got a little Mac 102 here. Let me just center it. And I got a little 13 millimeter Nagler, which gives it a nice view. So let's see if I can get this view of the moon here.
Okay. Now, how are you connected with this?
It's kind of hard.
Like your smartphone, or?
Yeah, so I'm using my tablet. Let me actually just point at the tablet here.
Okay.
So I got a tablet. I'm watching you guys there.
Okay.
Yeah, there's a bit of delay. Sorry, I can't. So and then I'm in my front porch here, and I got a little Mac 102. Okay. And normally, if it was a clear night, I'd have my C8 out, and I am looking forward to getting the ED80 FCD 100 from you soon here. Thank you. And basically, if I just try to get the moon in here, I'm trying to. I don't have an imager set up here, so let me just get this calibrated.
You do it to the tablet.
Yeah, I'm going to do it through. Here we go. I can probably do it this way.
Okay.
Yeah, that's the problem. Just a minute. Sorry about this.
No problem.
Oh.
It's tricky.
I'm still in the early stages of my imaging here.
Yeah, no problem.
As you can see.
No problem. I wish I could wind back all my astronomy experiences and start over from the beginning and go out again. You know, it's been, it's amazing to go through it, Even your first
There we go.
things. Okay, now the camera's not on.
There you
Ken.
go.
Your camera is not on.
Oh, it's not?
Nope.
Okay, let me just, is
There.
it on now?
Okay, now we see the moon. Yeah, there you go.
Oops. Oh, sorry about that. So, anyhow, I just wanted to take a quick shot of that, and later on I'll get better. I'll get better at this, and I really want to get properly set. I was actually not planning on joining you guys right away, but I just got so excited that I really want to get properly set up here. But we don't have too many clear nights in Seattle, so I wanted to share a little bit of experience here. So I'm going to look at the Rhine Nebula next, but I don't know if you guys want to hang around for that. I got the Pleiades. I can look at Pleiades. Let me just see if I can get Pleiades in there. Okay. I wish I could have a better real-time feedback here. Just give me a second. It's going to be kind of zoomed in.
Book Davey said it's not bad for just throwing it on. So.
Okay. Yes. Okay, so this will be just the, let me just get the.
Yeah, you have to get your camera back on.
Get the camera, so I'm just going to get this recalibrated here. There we go.
Okay, the camera's not on.
Yeah, what I need to do to make it actually work is I need to get it first with my.
I see. Okay.
There we go. I need to get it first with this guy. Let's see here.
You've lived in Seattle for a while?
Yeah, I've been here. You probably could tell from my accent, I'm Canadian, eh? And been in the States for since '99.
Okay.
And then basically, yeah. So I started my astronomy in Vancouver, actually. And similar to your experience, I saw my first wonderful experience when I was probably around 12 was seeing Saturn at 4 o'clock in the morning.
Wow.
In my backyard, and I was so excited. I called my mom out. I had a 4-inch reflector, Newtonian F5, and it was just so beautiful, so crisp, and it was just incredible. And yeah, I was hooked.
Right.
And then unfortunately, my work has really taken me away from the amount of time I really like to spend. So I've changed my. I used to actually have an 18-inch Dob. Loved it. I had it for 15 years.
Yes.
And did a lot of galaxy hunting and stuff like that. But then just didn't get enough time with it. So I found a good home for it. Sold it to a guy here locally who lives up north, and very happy with. Then I switched to little telescopes. So I'm really excited about ED80. I got a Lamac 102, and yeah, bear with me.
No problem.
Just trying to get the.
You're hanging out with.
Actually, I'm going to redo this.
Yeah.
What once I get this set up, it will be a lot better. Sorry for that. I just kind of wanted to throw this together because, like I said, when I saw the moon, it was like, all right, we got clear skies here in Seattle. So let's see here. So I'm just trying to. Okay, there we go. Okay. Okay.
Harold, Harold Locke says, Saturn is what hooked me. Once I got set up to take pictures, I have not been able to get a nice close picture or look at it again. Well, next season, Harold, shoot other planets until you get to get ready for Saturn when it comes back.
Okay, now, okay, so sorry for all that fiddling, but now I've got it set up. Okay, so I'm going to go switch to video. So this is the moon again. I just, can you see the moon?
Yes.
Okay, so now I should be able to go in. We've got Pleiades going on. A little bit zoomed in. Can I see it? Let's see. Let me switch again.
I did see a little bit of starlight at the edge there.
Okay, you know what? I'm going to skip to Orion because it's clouding over a bit. I got a convergence zone happening here in Seattle, so it just makes it all these clouds come in. So let's see here.
Your pals on chat are cheering you on, Cameron.
Thanks. I don't know about you, but to me this is real astronomy. I mean everything you guys are doing, all the talks, and then kind of the real time in the field experience. You know.
Yeah.
I just love to be able to share. Here we go. That's something. Let's see here. Let's see here. I can't quite see it. Let me just see if you can't see it yet because I'm using the phone. And I'm going to switch to the live view here pretty soon.
Okay.
That's, oh, that looks good. I think to top it all off, I'm not using any tracking. I think you say I'm just throwing this together.
It's okay.
I think this is it.
No, we don't see it.
Let's see.
We see your name.
Not yet, because what I need to do is I need to. Oh yeah, I think I see something here.
Okay.
Okay, I'm going to switch it now to the video. Right. What I have to do is I have to switch it back and forth between the camera view and the video. Oh darn! That was there. Oh, wait.
Harold says tomorrow he's digging the hole for the pier. Next thing you know, Harold, you'll be building an observatory.
Okay, I think I got it.
Okay.
I think I got the trapezoid here. Okay, can you see?
Just a little bit. Just a little bit.
Sorry.
It's
Let's
okay.
see here. I don't know if I can. I don't know if I can adjust the camera on the zoom. Anyhow.
I do see
well.
stars right in the very center. I do.
Oh darn. Okay. Well then, one last thing. Sorry if you're gonna. Since it's up, let me just look at see if I can get Mars. Okay. Mars is pretty small, but. Yeah, I'm going to have to switch back and forth quickly here. I wish I could control the zoom That'll be.
It's amazing that you're getting what you're getting with this, with the tablet. So not bad. Yeah, they didn't design the tablet for astrophotography. So, you know, that you're getting.
Oh, here we go. I got it. Oh. Problem is, it's with the Mac 102. I got a 13 millimeter Nagler, the 100 power, right? So, and I'm not doing any tracking. This is just all by hand. This is, you know, brute force.
Okay.
Sorry for that. It's but here we go. I got it, but it's just an orange blob. But you know, just darn it. Yeah, I should have turned in the. Next time I'll get it so that I have it. I can control the slow motion. There we go. Let me quickly switch now to video.
Oh, there it is. You got it.
You can use. Yay! I think I've taken a lot of your time already, but it will get better. It will get better. I definitely want to contribute and get involved more and have a better setup here. But like I said, just have a couple of things to sort out. But if I'd known it was a clear night, I would have been better prepared. But anyhow, thank you for letting me do this.
Thank you. Thanks for coming on to the program. Thank you very much. Yeah, you notice if you looked at the screen, you could see the planet slowly trekking across the screen. And you know, for a lot of beginners, they're startled when they look through the eyepiece and they see that, you know, it's already moved, and they go, "Oh, the object's moved." You know, no, the Earth has moved. Okay, this is what's happening. You're on a spinning planet here, so very, very cool.
Yep.
Very cool. Well, we are I think we're towards the end of this program here today.
Scott?
Yeah.
Oh, one thing.
Can I ask Chuck a question?
Yes, sir.
If we would send a large Hubble telescope near Pluto, would we could use it like a hub telescope for reaching that G11 area?
No. I mean, the percentage difference between GNZ11 and Pluto and GNZ11 and us is vanishingly tiny.
Okay.
I mean,
So
essentially the same
be,
distance. Yeah.
It has to be beyond Earth's clouds.
Well, actually, the GNZ11 image was a Hubble image.
Oh.
So,
but when they are going distance, and when we lose those galaxies, would we catch them again if we have powerful telescope?
No. And first of all, we're not in imminent danger of losing them. We're talking about a huge time in the future before those horizons move in to a point where we have any problems. So that's distant future stuff we're talking about there.
Okay. But there are some galaxies that we will not reach anymore because the expansion of.
I mean, the cosmic event horizon is simply a distance beyond which light leaving there right now can never reach us. It's there's too much space expanding and it's accelerating, and so the photons just can't make the trip.
So we will see about 14.3 billion years ahead, guaranteed, from the Big Bang.
Well, what will happen is over time, those most distant of galaxies that we're seeing will begin to get redder and redder.
Yes.
And redder
the red
and redder. Yeah, until they just are not visible anymore. And because of the stretching of the light waves from them. Mm-hmm.
Okay.
And I'd like to emphasize one other thing, Pekka. You made a very good point about history, about looking back in history, because I get questions all the time about, well, how could the universe possibly be unbounded? and yet possibly finite. It may be infinite, but how could it be unbounded? And I say, well, you have to understand that on our tiny scale, we just don't factor time into what we see. We see everything in nice flat three-dimensional, in a flat three-dimensional way. But if we were bigger, if let's say you're 40 years old and you're 40 light years tall, look down at your feet. What are you going to see? You're going to see baby feet. Yes. Everything will look different when time is a big factor in what you see. And so it alters things we see. Yes. But being small, we just don't see time as an issue in terms of how it alters the shape of what we see.
That's a good point. I will use that.
Go ahead.
And one to Astrobird, maybe. How important is accurate polar alignment when you are photographing moon in very high?
If you're photographing the moon, I'd say almost not at all. It's just for tracking purposes. You're going to chop the frames so fast that it's not going to matter. Same for bright planets. It's more about tracking, just so it doesn't move in the field of view. As far as if you want to go unguided for long subs, depending on how precision your mount is, it's ultimately important. And then the other thing would be to say is that if you have guiding, you can get away with kind of throwing it down, doing a polar alignment, but the guiding will take over for it anyway. As long as it's close enough, you won't get field rotation. Like if you have an alt-az mount, you'll have blurry stars around the outside of your image and stuff. But as long as you're close, if you have guiding, you can you can get away with not polar aligning so good.
Because I want to take really a very high-powered
doesn't matter
moon photograph, so polar alignment is not an issue as long as it's roughly.
It certainly can be, but if you're guiding, it's not as much of an issue that it's perfect. You still have to have it pointed in the general direction, but the guiding will follow the star regardless.
Yeah. I'm talking about the moon. No.
Oh, the moon doesn't matter at all.
Okay. So I want to take a very high powered close-up moon pictures of craters and mounts and
if you're going really high power, you're going to want to at least have it polar aligned somewhat. Just so everything stays in the same place. But, again, depending on how much power exactly, what your focal ratios are is going to determine exactly what your frame chop is. If you go from f4 to f20, you're going to have a very wide, variance of what your frame chop times are going to be, even though they're all probably going to be below a second. Some of them are going to be like, milliseconds chopping real fast. And if you're at f20 or something, it might, be half a second or something. I don't know. I don't have it all right up there at the moment.
Okay. What do you think about F10 CST 11-inch with ASI 178 mm?
I mean
2.254 pixel.
Again, it's going to be, I don't know that particular camera, but it's going to be about quantum efficiency, everything to get from what one person has to what another person has for how well those pixels pick up light and
the atmosphere.
But F10 is going to be 8 times longer, than like F4 or something like that. Somewhere in that.
Thank you.
Yeah,
Thank you. Thank you.
Scott, I got one last thing, if that's cool.
Yeah, of course.
All right, we're going to share this screen here.
Kind of a hangout session environment.
I've been waiting for this to come back since last year.
Oh, okay. I see.
Somebody mentioned Markarian's chain earlier, and I've been waiting for it since last year. Unfortunately, my camera's turned about 90 degrees from the side from the way I'd like to see it, because we got the chain coming through here, and it'd be a whole lot cooler if it came through here. But we got the eyes here, and there are just tons of galaxies.
Oh, yeah.
We got little faint guys in the background, and hold on, I got to move this thing on the side here. Got the elliptical here, the boring ones, the bright puffy ones. Good one there, there. Another one, another one, another one, another one.
So Charles Mercier discovered the first of the two galaxies, which is M84 and M86 in Markarian's chain in 1781. It says the other galaxies seen in the chain were discovered by who? William Herschel, who discovered everything.
Yeah, I think I'm just outside of the M87. It's down off to the side, but
that's right.
You just wanted to show that. That's hold on, how many frames is that? That's 8 5-minute subs. So
excellent.
You could definitely get a whole lot more out of that one.
Yeah.
That's good for me tonight. I showed all I need to show.
That's awesome. That's awesome. Yeah. So this is Markarian's chain is Virgo cluster galaxies, I think. Mm-hmm. Yep.
Yeah, it's always cool because even if your go-to is not completely on, you're like, okay, galaxies. Now I just need to see which ones are where. It's kind of like plate solving, but a lot easier than with stars because you're like, okay, those look like that.
Right.
I set up a little bit fast. I was a little off tonight.
Oh, no, it worked. It worked out, which is great.
Yeah, the clouds didn't break till it was kind of too late anyway, but
yeah,
made it work.
Thanks, Richard. That's awesome. So Pekka, my email address is just the letter S.
Yes, I know. Thanks. Yeah, I have it.
So send myself and Jerry Hubbell, who's JRH at Explore Scientific, and
JR.
Yeah, JRH.
JRH.
We will get you set up with the MSRO telescope.
Wonderful. Wow.
Some more clear skies than 6 nights a year. So
yes.
Okay.
It has been terrible over Stockholm.
Yeah.
You know. And yeah, because you have to have exercise. You can't just read and listen and watch YouTube movies. You have to get out and try.
That's right. That's right.
Because that night I want to make a very good picture. I don't know what to do.
Heck, I just chat message my email to you. I'd love to stay in touch with you.
Oh, thank you.
Yeah.
Thank you. Should I, could you, Scott, do you have my email address or should I?
Yeah, email me and I will have your email address.
Yeah, you can spread it. Thank you very much, everybody.
My grandparents, my mother's side, are both from Sweden. So
yes, you. Yes, you.
I didn't know if you'd seen that. Yeah.
Yeah. Are they still?
No, they've been gone for quite a while.
Yeah, but have you relevance in Sweden?
I've been there. I've visited relatives there on 2 occasions. Yes.
Okay, you're very welcome, and just notice me. Then I can show you the whole Stockholm and the hidden fortunes.
That'd be wonderful. Thank you.
Because they are tourists. They are showing it just the same, but there is so much more to see. What not in the books and so on.
It's a beautiful city. The times I visited, I loved it.
Yeah, so. It has begun to be too violent and so on. And now COVID. And
now COVID, yes.
30% don't take it seriously, so we have a 3rd wave ongoing here now.
Oh boy.
Yeah.
Only 30% there.
Yeah, but you know, the government says you can take train and the authority for health. They said no way, and there is so many different points of views here that nobody knows how to act.
Yeah, same here.
Yeah.
Same here. Same in a lot of places.
We are on the same boat.
Yeah.
Let's just see that the boat are going to right direction.
Yes.
So
I think we're getting there. I saw a graph today And for the first time in a long time, there's been a great diminishing of hospitalizations for COVID in the United States. So
yeah, I saw that graph too today.
Yeah,
the first time. But
right.
For me and kind of me who has made this big surgery, we if we take the vaccination, they don't know if it's not some effect at all. And somebody tells when you have the vaccination, you are free to go out. But they don't know what to do with us who has lower immunity.
Yeah, yeah.
And now my medication is pushing it even more down. So if I see somebody who has cold, maybe I will get to very deep in hospital. So for me, it's a little bit. I'm sitting here and studying everything, even astrophysics and cosmology.
Good.
I was looking at a Finnish program. There was one astronomer and one cosmologist and a priest, and they was discussing about everything. And the question was, how long can we continue with reaching to the cosmology? And our brain is the limit. Only our brain. When it stops, understand that there have we our limit for cosmology.
Yes. I'd read somewhere at one point, it was, I love armchair cosmology. I'm not a physicist or, I'm a telescope maker, and I love the sky.
You do that well.
Astronomy, I do. But one thing that cosmologists brought up, and I can't remember who it was, but he basically said that if we could imagine it, if humans can imagine it, that probably somewhere in some dimension of the universe, it's out there, and that's something I think about a lot, because I think that the effect of a scientist doing, observing an experiment can influence that experiment just by observing it. Why would that be? Why would that be? So I think for a long time there was the effect of, if we wanted to see photons coming through a slit from light, if we wanted to detect photons, we'd detect photons. If we wanted to see light waves, we would see light waves. I think there's now an explanation for that. Okay, a new explanation for why it was that way. But when we were kids, black holes were, they thought maybe black holes were out there, but it was really in the realm of almost science fiction, and now we have the first ever photograph of a black hole, so it's interesting. It's all interesting to me, and the mind and the universe is, I think, some way hardwired,
Cygnus X1's right next to the Tulip Nebula, isn't it?
I don't know.
I think it's within the same field of view if you image the Tulip Nebula. Of course, you're not going to see the black hole, but never know if there, might be some gas moving around or something because of it.
Some gas moving around. That's right. Yeah. Have you ever tried to visually observe 3C273? It's a quasar.
Sure.
Yeah. I was surprised at how small and faint and star-like it looked, you know, when I first saw that. And the first time I saw it, I was at Palomar Observatory, or on the mountain by Palomar. And one of the professionals came down, and I was excited. I said, yeah, I've seen my first quasar. And I described it to him. He says, that's what it looks like in the 200 inch too. You know,
yeah, exactly. There's one
so far away.
There's a quasar in Lynx that is 12.2 billion light years of light travel time away. That's visible. It's magnitude 15.2. With a proper chart, a moderate Dob can pick it up.
Yeah, right. I'll have to try that.
That'll be your distance record. Trust me.
Well, it's been a great show. I want to thank you guys for hanging in there with us. Chuck, I want to thank the Astronomical League and all that you guys do. I know that you guys rotate and do this, but we love having each one of you on. The audience really enjoys your presentations, Chuck. You do a wonderful job. It's great, and I learn something every time. Richard, you've been on, I think, every Global Star Party participating, and it's awesome to see your work increase and improve over the months that you've been on. It's great. And Pekka and Cameron, it's wonderful to have you two join us. You know, I know it's your first time to be on maybe you've done other shows like this, but it's great to have you on, and you're welcome back anytime. So
thank you, Scott. It will be a pleasure. It's so fun, this, and you learn every time something new. Every time. Me too. So it's a pleasure, an honor.
Thank you very much. It's an honor.
Thank you so much.
Thank you,
Cameron. Take care. You guys.
Good night.
Good night.
Good night.
And
it's really nice here.
See you tomorrow. I'm only going on the 18th. I'm going to broadcast early, probably only to show you links of where you might find other information about the Perseverance landing. It's going to be pretty easy to find, though. You know, and it's going to be millions of people are going to be watching it. So I don't want to interrupt that watching time for the landing and the follow up on this. So anyways, but we will see you tomorrow's Wednesday, and we will see you tomorrow. And until that time, just as my friend Jack Horkheimer would always say, keep looking up.
Okay. Good night.
Good night.
Good night. Thank you.
Thank you.
And now, folks, it's time to say goodnight. We sincerely appreciate your patronage and hope we've succeeded in bringing you an enjoyable evening of entertainment. Please drive home carefully and come back again soon. Good night.
Wow.